reference for. The third one is called the lag in reference file. So we have compared the computational overhead first, particularly on user equipment and the core network. We find that all scheme will have a nice, will have a reasonable time consuming for the computation cost. So which is 15.62 millisecond, while the other two, the first one has less computation cost, while the other one has larger computation cost. We further consider the communication cost. So the communication cost will have two portions. One is the transmission overhead, the other is propagation overhead. Eventually, we find that all scheme has the lowest communication overhead, which is 224.94 microsecond for the communication purpose, while the other two will have a higher, will take much more time for the communication purpose. We have also performed the simulation to verify the performance of the proposed scheme. So we found out our scheme, which is in blue curve, has shown reasonable performance under the unknown attacks. So basically, it is supposed to be a little bit higher than the IoT, 5G IoT D2D, while the is lower than the lag scheme. So this is the supposed to be the last slide. So as we mentioned that we propose a ECC D2D scheme, which is suitable for resource constrained 5G devices, including the 5G cellular phone and IoT devices. We are going to, with this design, we are going to secure the so-called policy service specified in the 3GPP standardization, particularly in two processes under this umbrella. So one process is a device discovery process, the other one is a one-to-one direct communication process. So we have, claimed that some common malicious attacks could be prevented. Particularly, we are able to prevent the free riding attack. So basically, this is the end of my speech. Any questions, you are welcome. Any questions from the floor?
Okay, thank you very much, Professor Maudema, for a very nice presentation and lots of networking, even though the conferences belong SCI. So I would like to know one very small question. Like, there are the Internet of Things and 5G network. What is the relationship between IoT and 5G network? Do you think it is going to be useful, 5G network, for IoT applications? What is your point of view here?
It's possible. It's possible. There are some sensors to use a 5G interface to get a connection to the 5G genome B, the base station. There are some devices which, the purpose of using this is going to speed up the communication process to deliver the information collected by the sensors to the remote sessions to the applications. It's possible since the 5G has been deployed everywhere. Why not use this 5G to support the IoT applications? So otherwise, you have to use some special equipment or deployment of the system. Then that is a waste, kind of waste of the investment, right? So I believe in Korea, a lot of 5G service are already there. Is it true? Well, in Singapore, not started. They just start to identify who will provide the service, which equipment will be bought, as kind of thing. They have not commercially to provide the 5G service. I believe in Korea, everything is already implemented. Am I right? 5G, are you using 5G cellular phone? Are you using the 5G phone?
But it could not be a very expensive for IoT applications, like the peoples are going to use 50 device, and if they are going to consider 5G networks.
Yes, it depends. Because if you don't use a 5G, you need to set up another system.
Right.
It also needs the investment, right? But the 5G are already deployed in Korea, right? So that why not we just equip one interface for the sensors to let the sensor be able to get connection to. We will not have much more money for the the other equipment to complete the IoT service. Of course, if you have already deployed the IoT network already, there's no need to use the 5G. But if you have a new system to be deployed, then you may consider this balance, whether to use the existing 5G infrastructure or you need to deploy a new infrastructure. Although they technologically they may not new, but you need to buy some other equipment for your IoT system to be deployed. So this is my consideration. Of course, if you have already the IoT system, no need to have the 5G upgrade. But if you design a new IoT system, you may consider to seek the balance, whether to use a 5G sensors, or you still use the old system. Well, the old system still needs you to invest the major equipment besides the sensors, right? That's my consideration. Why I talk 5G, because it is very popular now in Korea.
Right.
But even in Singapore, it's not so much. This is my consideration.
Yes, right. Actually, one of the startup company in Korea, they are making on their robotics for security purpose. So what they are trying to do, that they are installing the robot over the metro station, and the robot will drop the late peoples who are going their home nearby 1 kilometer and 1.5 kilometer, and they are using the 5G network connectivity there. It's becoming more expensive.
Yeah, this is a very good example for the IoT system. You gave me the example.
Yeah, so just for the security purpose, so I was associated with that company. So what we had idea that if we can make a community network like the city based Wi-Fi network, or the based on the the advanced technology, like we can use concept from the 5G and future internet architecture, and we can install the base station inside the city, for example the Seoul city if you are talking about, and they can use the they can support the IoT applications, this kind of public services as well. So what do you think about this kind of network? Means autonomous network instead of using 5G network? That's my question.
Yes, because the 5G is already deployed everywhere in Korea, right? So you why not use it? Otherwise, it's still a waste of the resource, right? So this is my consideration. So you give me a good example for me to address this issue.
Any other question you guys have? Please ask your question directly to the professor. He's here.
Korea is very advanced on the information and communication.
Any question from audience? Sejing, you can ask any question. Yes. Yes, you can ask. You open your mic there. Is it on?
Hello.
Yes.
Yeah. Hello, Professor Mao. Just can you me? Yeah, I have a question about this.
Come here. Yeah. Thank you. Thank you, Professor Mao, for this your nice presentation. I have the question about this ECC, about the like nowadays we are looking for the lightweight, right? ECC has the complexity and they have a scalability problems. So is it can possible to use in like 5G and this it can be scalable, or latency issues like there is not that much lightweight, right? Compared to when we use for this IoT devices. And for this
yes, but you know, the way we overcome this computational overhead brought by the ECC is that we try to move the computation portion to the core network rather than on the user equipment. By this way, it's possible to to let the user equipment to have a less computation, so that to contribute the less computation overhead. So this is our strategy to balance the communication overhead. Of course, you from this table you can see that our scheme is not the perfect one which has achieved the lowest computation overhead. However, it is a little bit reasonable. What I see is reasonable because by our scheme is able to prevent some kind of attacks, while the one with the least computation cost may not be able to protect this so-called free riding attacks. So this is my consideration. So everything is not perfect. Everything is not perfect. Everything is going to achieve the balance or trade-off between the performance and security function. Okay, this is the goal of our design.
Yeah, thank you very much.
Professor, good morning. May I have one question?
Yes, please ask.
Yeah, Professor.
Yeah, we can listen you. You just speak question, no problem.
Sir, my question is that in device-to-device connectivity, is it possible to identify exactly a device in this current technology-based environment? We just can use, instead of mobile, we can use our laptop by irrespective of the location. So if I'm connecting a system, I'm connecting with my mobile 5G technology, and this mobile is connected to the laptop which is in another location. Is it possible to identify exactly that the transaction is happening from the laptop or from the mobile? Is it possible? Because of the forensic application kind of thing. Sometimes it's happened that somebody will do malpractice kind of thing sitting in the other system, but using the mobile technology of the another location kind of thing. Is it possible?
Yes, it's possible. However, we need to have some other design extension based on the current scheme. But this current scheme I presented is not particular for your scenario, but it's possible to to design an extension of my current scheme to realize what you have mentioned. You mentioned that whether it's possible for laptop while it is somewhere in a remote site can communicate with this device. It's possible, but it needs some other extra design based on the current presented scheme. That is what I mentioned. The other condition for the communication is that the laptop should also have the 5G interface. While the current phones without a 5G interface can also not be able to be used in this scheme. So that, for example, the current cellular phone with LTE or 4G communication interface cannot use to support the 5G. This is the case. Why I present this work at this conference, because I understand that Korea has a very strong on the information communication technology, so that they have already deployed 5G networks. So that I simply present this work to share with you, the guys in Korea.
Thank you, Professor.
So just now, Professor Tsai has a very good example to provide to me, that there is a company, robotic company, that want to get the communication between robotics through 5G technology. Well, my scheme is able to equip it that products for the communication between the robotics. Okay, I think that's a good example provided by Professor Tsai.
Thank you, Professor.
Yes. Any other question? Anybody? All right, then I think let's give thanks to the Professor Maudema. And thank you very much, Professor, joining. So let's clap for you.
Thank you for your time and patience
Thank you so much.
on my speech. I think that's all. I will stop sharing.
So now, yeah. So we have a next speaker. So he is going to present here on the desk. So I think Professor Chung going to introduce him very briefly about that. So then you can continue.
Okay, we will going to next invited talk by Professor Jae Ba. I will shortly introduce Professor Jae Ba. He is now full professor in the Department of Electronic Engineering in Gaemyeong University, Daegu, Korea. He got his PhD from the Texas A&M University College Station in USA. So his talk title is Plastic Optical Fiber Sensors based on inline micro holes. Okay, Professor Ba, please come. So he visited here on site and he will deliver his talk. Yes.
Just करो जल्दी USB में PPT open करो. USB drive. This one?
Yeah.
चल रहा है? Thank you. From here, F5. It's okay, it's Zoom. Yeah. Okay, thank you.
Hello everyone. This is Jae Park working at Gamyeong in Daegu. Before my car was out of order just after parking. So I am worried about it. But right now I am not concentration on my speaking. If I make a mistake, please forgive me. Before having presentation, I will introduce my university, Gamyeong University. Gamyeong University is located in Daegu, third largest city in Korea. Gamyeong was established about 110 years ago under the education philosophy for kingdom of truth, justice, and love. Gamyeong is multicultural university. A lot of foreign students are studying right now. 제가 너무 작아서 그래요. 조금 들면 안 되나? 이러면 될 것 같은데. Over 20,000 students are studying, and the campus is the most beautiful place in Korea. Today, I am talking about the plastic optical fiber sensors based on inline microhole. I am talking about it according to outlines, motivation, background, fabrication method, POF sensor, summary, and the future work. In this presentation, I reviewed the POF sensors based on inline circular microhole. I will introduce three kinds of POF sensors based on inline circular microholes. All were developed in our lab. I will show you I explain fabrication method. I will show you the analysis result, theoretical analysis result, and the experimental analysis result of POF sensors. The plastic optical fiber sensors has been overshadowed by the success of the glass optical fibers, although developed at the same time. However, plastic optical fiber sensors have made an alternative to glass optical fibers due to the recent technological advanced. Furthermore, the plastic optical fiber are expected to be the fiber of choice for the next generation of advanced optical fiber sensors. Plastic optical fiber sensors have all of the merits of glass optical fiber sensors of a conventional sensor, including immunity to electromagnetic interference, rapid response, suitability for remote sensing. More additionally, plastic optical fiber sensors have merit of glass optical fiber sensors, such as easy handling, high flexibility in bending, high sensitivity to strain, and so on. First of all, I'm sorry. First of all, the characteristic of the inline microhole based on POF sensors are theoretically investigated. That this is the picture is the schematic diagram of the POF sensor based on inline microhole. The multimodal POF plastic optical fiber sensors have more than 1 million modes in the visible wavelength range owing to the millimeter order core size. So theoretical analysis was performed from a ray optics perspective. Before obtaining the transmittance of the POF sensors, we have to consider some points. If there is no force, the ray passing through the point BP, when the angle to the 5-axis is less than theta V, propagate in the fiber without loss. When there is an inline hole, ray passing through the point B with an angle less than theta V and greater than theta A, propagate without loss. In the case of rays with an angle less than theta A, the ray passing through the hole and arriving with an angle larger than theta C at the core cladding interface travel into the fiber without loss. Otherwise, rays are lost owing to the refraction at the core cladding boundary. The equation, the equation is the transmittance equation. The transmittance of the plastic optical fiber sensors is a function of the refractive index of core or cladding and the hole size and the refractive index material filled in a micro hole. I'm sorry. The glass optical fiber, the optical fiber with the inline micro hole have been making great interest. The micro hole in the single mode glass optical fiber was made using chemical etching and the femtosecond laser processing. The several glass optical fiber devices based on inline micro hole has been developed and showing good performance, but the expensive equipment is needed for making inline micro holes. Recently, the development of the POF sense based on inline micro holes fabricated using inexpensive equipment has been reported. This is the fabrication setup for making inline micro hole in POF consisted of the inexpensive drilling machine or microbit, the laser diode, and the power meter. The inline micro hole was produced while monitoring transmitting optical fiber. The POF with the core diameter was 1.48 and the cladding and core refractive index of 1.49 and 1.41 was used for making plastic optical fiber sensors based on inline micro holes. This is a picture. These are pictures of the inline micro holes. The right side is a single circular hole. Middle pictures, 3 circular holes. The last one was the rectangular inline micro hole. Holes were fabricated using this fabrication setup. First of all, the plastic optical fiber refractive index sensor was investigated. The plastic 5 refractive index sensor was a plastic optical fiber with a 7.7 millimeter diameter holes. For the analyzing the characteristic experimentally, 3 liquids were used: water and dodecane and glycerol. The transmittance were obtained as that the liquid put on the inline micro hole in sequence from lowest refractive index to highest refractive index. The picture, look at the picture, the red one was theoretical data, and the black one was theoretical data, and the red one was the experimental data. Both the transmittance increased as refractive index increased. The sensitivity of this sensor was 13.4 dB per RIU. The measurement index range was 1.33 to 1.42. From pictures, the pictures shows that the experimental and analytical result were in excellent agreement. That the difference between theoretical data and the experimental data was about 6%. The difference was made due to the ignoring fractional refraction, screw ray, and scattering due to the hole surface roughness. The high sensitivity POF sensor, high sensitivity POF refractive index sensor was produced with POF with 3 cascaded inline micro holes of 0.7 millimeter diameter. The sensitivity of this sensor was about 43.8, about 3 times sensitivity of the 0.7 single hole sensor. This result indicated that the sensitivity proportional to the number of the inline holes in the POF. Second sensor, the plastic optical fiber level sensor was developed. The plastic optical fiber level sensor was POF with 8.9 millimeter diameter holes spaced 5 centimeter apart. This is an experimental setup. Experimental setup consisted of a raised diode and power meter and the cylinder. Very simple. This picture, the horse showed horse face. The black one was the theoretical transmittance, and the red one was the experimental transmittance. The theoretical data, the theoretical transmittance was calculated using this equation. T1 is transmittance of the sensor with 1 inline 5 hole filled with water. N is the number of the in-fiber holes immersed in water. The transmittance, both theoretical transmittance and experimental transmittance increased with the number of the holes immersed in water, because water refractive index is close to the core refractive index than the air refractive index. This picture shows that the experimental data were in good agreement with the theoretical data. I will introduce last one, that the plastic optical fiber respiration sensor. The plastic optical fiber respiration sensor consists of a plastic optical fiber with multiple inline holes drilled along the POF, stitched to the waistband wrapped around the patient abdomen. The stable plastic optical fiber sensor with a different number and the different space of the 0.7 millimeter diameter inline hole were developed but the sensitivity is proportional to the number and the space. However, that the plastic optical fiber respiration sense with 7 holes spaced by 50 millimeters have best performance for monitoring, respiration signal monitoring, respiration monitoring. That the pictures, the top one was that the respiration signal from the plastic optical fiber sensor. The bottom one is the respiration signal from commercialized respiration medical device. This picture indicated that the performance of a POF respiration sensor is similar with the performance of the commercialized respiration monitoring device. The experimental result indicated that this POF respiration sensors can be used for monitoring patient respiration. I reviewed the 3 POF sensors based on circular inline microholes. The experimental results and the theoretical results were in good agreement that all of the POF sensors had good sensitivity and sufficient strength. Future work, I will investigating POF sensors based on different shape inline microholes in future. I will develop POF gas sensor. I will develop multifraction and distribution technology. Thank you. Have a question?
Any questions? Okay, thank you very much, Professor Park. So any questions? Okay, Professor Khan.
Yeah, question is that
Come, use this.
If we want to use sensor device inside the cotton mill, I got one of the requirement. Cotton mill is there, the cotton factory. They have big cotton. No? And they want, because they have every year they about 40% average. I heard that they have accident because of the warm, and they make the fire inside the cotton factory. So what they try to do that, they ask me if there are any sensor we can install in the bundle, and then we can take care.
Not right. In the future,
Right.
I have a plan to develop this kind of sensor.
Still now not available.
Yeah, not available right now.
Right now not
The
available.
experiment was done. It's not done.
Not done.
Yeah, so right now we are doing it.
Wow, very nice. Because they have requirements, and they ask me if this kind of sensor developed, because
Wide area, cover
Yeah.
wide area. Yeah.
Right. Because the cotton is also itself, it's a hot, so you cannot install normal sensor during that time, and they have to measure long times as well. So due to accidents, I heard that lots of accidents happening in those factories.
Yeah, so I'm not sure, but we are developing this kind of sensor.
Yeah, very nice.
Using this.
This calculation. Okay, thank you very much.
Thank you.
Okay, maybe to cover the wide area by the several sensors. One of the merit of the optical fiber sensor is covered a very wide range, right, in a very stable state. So, Professor Park, come. Okay. Okay, so we will turn over to next invited talk. Okay. Our next invited speaker is from Bugyong National University, Busan, Korea. It's Professor Yeon Jung is also a full professor in Bugyong National in Department of Information Communication Engineering. Okay, he is the head of a mobile optical transmission system laboratory. And okay, sorry. And
okay. Can you hear me?
okay, that's right. Yeah. Okay,
Okay.
he got his PhD from Liverpool University in UK, 1996. Okay, Professor Chung, please.
Okay. Thank you very much, the Professor Chung. Okay, it's my great honor to present the my work on. Okay, so I'm not sure how much you are. I mean, you are all familiar with this wireless communications. So
Professor
I'm actually,
Chung,
yeah.
excuse me, Professor Chung, you
Yeah.
may use dual screen, right?
Right.
So it's, we can watch only half of your screen.
Oh, so hang on then.
Okay, move to the
Okay, let
completely
me
to the
switch off the.
one monitor.
Yeah. Okay.
Zoom F5 or Zoom F5.
Okay, is that okay now?
Can you push F5? Oh, now it's okay. Yeah.
It's okay.
Yeah, now okay.
All right. Okay. Right. So, you know, my topic is a little bit skewed from the main theme of the conference, probably. I'm not sure though, but my work is is optical scattering communications, so which is a relatively new topic in wireless communications. And I'm Yono Chung from the Bugyeong National University. So based on my students' work, who carried out some very significantly, in this area. So let me just move along with what we have got. So hopefully you enjoy the presentation there. Okay, so this is an outline of my talk. So basically, I will actually introduce the optical wireless communications, and particularly ultraviolet communications, so which is relatively, somewhat complicated, but it's useful and hopefully very useful in the future. And I would introduce some system model, and based on the model, which we actually derived a couple of years ago, and then we actually are working on this model, and also we extending our work to incorporate some new features, and also to address some new challenges in the in these wireless communications. And then we did a little bit of simulations, and I'll share with you some results we obtained. And finally, I'll draw the conclusions. Okay, first of all, introduction to the optical wireless communications. I think some of you are maybe a little bit familiar with these optical wireless communications. So we are very well aware of the what we have in the electromagnetic spectrum. We actually more or less becoming congested in the electromagnetic spectrums. So, it's a mature RF technologies, and we're all, but if you see what's going to happen in 5G, already, our, previous speakers are talking about some 5G technologies where we actually need to ensure the massive connections with the massive number of devices and the systems. So then obviously, how we cope with this demand on connections. So obviously we see a lot of challenges, particularly spectrum scarcity. So that is how we evolve the some optical wireless. So in other words, optical spectrum. So there's in optical spectrum, obviously, more or less very vast, the bandwidth and the very high speed data transmission. Whereas, so in electromagnetic spectrum, a very limited capacity and costly deployment, of course. So, why we not, turning to some new alternative, which is optical spectrum. So that is how I so much, enthusiastic about this the light spectrum. So we look at some increasing demand for high speed, high capacity, and high integrity, and moreover, high connection, so massive connection. So that is we see great challenges in few years to come. So that is how we started the this optical wireless communication work. So our contributions in this work is we developed a statistical model based on Malaga distribution. So it has many distributions already proposed in addressing what's going to happen over the atmosphere when you actually transmit the optical signal. So we considering some Malaga distribution. Why? Because this is a very much empirical, and then it's very effective in line with what's going to have in the real experiment. So it's very much is in line with the what we're going to observe, what we're going to obtain. So that's why it's becoming popular now, unlike previous distributions such as the gamma distribution or log normal distributions. So that is actually addressing some turbulence distribution. In other words, the fluctuation over the signal you transmit. So that's the one we actually believe it is a great contribution. And the second point of the contribution is we present the trade-off between the power and the bandwidth requirements for the analog links for different modulation schemes. Well, I mean, you know, in the optical wireless communication, so one of the major limitations, or so to speak, is kind of limited power. So we cannot, you know, make use of the all available power. So that's the one we need to. So this is, you know, my second point of contributions.
पिवळेकर सर अजून जॉईनच नाही केलेली सगळी चिंचॉंग वालीच आहेत इथं दिसतं की कोणी जॉईन केलंय
So is there any problem?
बुनगिनली ती एकच लिंक आहे त्याला जॉईन करायचं सेशन 2 मध्ये माझं आहे
Okay, I think it's just somebody's interruption, I think. Okay, so now then the optical wireless communications here. We basically three types of the optical wireless communications here, and the visible light, and the infrared, and ultraviolet band. So, which is UVC. We actually going to talk about more. Then you know, OWC uses either UV or IR or a visible light emitting diode. So as a transmitter, and a photodiode or the photon multiplier tube as a receiver here. Right. So as I said, I mean, you know, the major advantages of OWC, particularly, you know, in many optical spectrum, so, you know, abundant the bandwidth available. So without any charge, without any, you know, cost. So here, you know, theoretical bandwidth is like 200 terahertz in 4 to the 1500 nanometer range. And it's very secure connectivity. In other words, because it's very narrow optical beam we're talking about and transmitting our data. So compared with RF waves, so it actually in a very wide, you know, the you know, beam over the air. So obviously, you know, less secure, I mean, so to speak. And then like just you know, RF it actually is invisible, you know, IR or UV cases, and hard to find and even harder to intercept. So unless you are actually in the vicinity of the intended user, it is almost impossible to intercept or to find the signal. And then lower power and miniaturized transceivers we actually do. And then, of course, it's very much immune to any electromagnetic interference there. So let's have a look at some how actually OWC is, you know, classified. So we basically two types of OWC, indoor and outdoor. So VLC is the very popular one nowadays, and a lot of LED-based indoor communications, you know, for positioning, for transmitting signal. And for other, you know, applications, it's becoming mature now, so it's very well known, but still not yet, you know, implemented in practice, and no any commercial technologies as you know, are being developed at the moment, as far as I know. And the infrared is particularly useful. And outdoor, for example, now FS is you know, free space optics. It has been around for many years. And you know, a few practical applications we see nowadays, and the VLC and IR. And then also there's another one is, this is what we're talking about, the UVC. Now, non-line of sight, you know, ultraviolet communications we're talking about. In other words, So, transmitter and receiver there, and then we actually transmit it into the air, and obviously receiving, sorry, the other way around. I think this is the TX though. I think, so in the receiver, we have some, FOV, field overview here. And then obviously, we see some common volume. And then through the scattering, we received a signal through that. Yeah, in ultraviolet, for example, we see from 4 nanometer up to 400 nanometer there. So we see particularly a middle one, which is this part between 200 nanometer up to 300 nanometer. So that is a spectrum we're actually working on. So MUV is primary focus for wireless UV links. Particularly this one is solar blind at the ground level, so relatively low dark noise. And of course, there's less atmospheric absorption here, again, compared to EUV or FUV. So just few examples are envisioned, not yet, commercially available yet, but somehow in the future, we guess, it may be, maybe on the market. So particularly distributed sensor networks and aircraft, landing assistance, and in military applications, unattended ground sensor networks, and small unit communications, and ground air communications, and covered networking, and missile and artillery fire detection. So those, applications are, on the horizon. Well, one thing, one caveat is just like a safety concern. Of course, when you talk about UVs, obviously we need to make sure that UV power level is pretty limited according to the international standards. So for example, for continuous UV exposure, it should be less than 0.1 microwatt per square centimeter. And also, for less than 7-hour exposure, it should be less than 0.5 microwatt per square centimeter. Right, the atmospheric factors affecting UVC, we're talking about two types of attenuation here. So scattering and absorption. So we see these two attenuating factors are combined together. So that is composed of, total attenuation. So that's exactly what I explained earlier. So we see through this common volume there, which is, of course, is formed somewhere in the atmosphere, and then through that scattering, we actually detect the signal. So that's why we pretty, important to characterize this channel behavior over that atmosphere, because there's a lot of things are, happening over the air. As we have, aerosol and fog or rain, and there's a lot of, factors need to be considered in characterizing these UV communications. So for that reason, we are looking at scattering mechanism of the UV signal here. So we see two types of scattering. So scattering is a main medium of the UV or other optical wireless communications for outdoor applications. So for example, here we have a Rayleigh scattering, and another one is a mere scattering. So two types of scattering, depending on what you have over the air. Okay. UV signal is ideal for NLOS communications here. And then particularly very small air molecule, for example, then we characterize it as a Rayleigh scattering. And then when it's a large one, such as fog, haze, rain, etc., is characterized as mere scattering. So these two types of scattering occurring during the transmission. So as I mentioned earlier, this is kind of distribution we normally use for the analysis. So log normal distribution, for example, widely reported model in the literature. So unfortunately, it is only valid in weak turbulence fading, okay, and the single scattering event. And then now experimentally verifiable model introduced, which is called the gamma-gamma distribution, which is valid under all turbulence fading conditions here. And the Malaga distribution, we more or less, well, it first proposed by one researcher in Spain, but we refined the distribution expression, and it is very valid under all turbulence fading, like the gamma-gamma distributions. The one beauty of this Malaga distribution is it unifies most of the existing distribution models, okay? And it shows excellent match to the experimental data. That is another advantage. That's why we keep on using Malaga distributions rather than any existing distributions such as log normal and gamma-gamma distribution. Okay, system model. Well, this is all parameters we actually use to describe the transmission. And again, you can have a look closely if you're interested in. So basically, just parameter, the parameter definition. And this is a statistical model we developed. So received signal is Y, and then that is consisting of our receiver sensitivity, receiver responsivity, and the channel gain, again multiplied by transmit power, and then this is irradiance I, okay, and then Gaussian noise N is there. And then we developed the marginal PDF of I, which is irradiance, okay. So that is irradiance. Sorry, because of the writing on the screen there. So that is a PDF of irradiance. So we developed first time, and this equation, actually my students, they developed this, this equation, which is very useful, which characterizes the channel or fluctuation as a Malaga distribution. So there's many other model parameters describing this marginal PDF, and also some modified Bessel function of a second kind. Well, let's have a look at simulation results. So in order to verify our model and also the power and the bandwidth requirement, so we conducted some interesting simulations with the parameters given in this table. So we normalize the bit rate because we are not interested in the bit rate, because we want to define the optimized balance between the power, transmit power, and the bandwidth. Okay, so that is the reason why. And then we used some different optical modulation schemes, such as on-off keying and pulse position modulation and digital pulse modulation. And also we used the double header digital interval modulation. So we use the various the modulation schemes there. So basically we learned through based on the expressions we actually developed, and then we actually found some results. Right, so before I show you the simulation results, this is kind of two types of the modulation we actually employed on top of the on-off keying here. So this is DPIM, so digital pulse interval modulation. So basically, depending on your the modulating signal, so we actually using interval to express, to convey the information, the modulating signal. So the larger your signal is, and the more intervals you have, okay. And double header PIM, which is two types of headers we actually use. So depending on the MSCB, the bit, so we actually use two different types of the header we use. So if you're interested in, so I just put some source here, so you can have a look at this thesis published by the Sheffield Hallam University. So this guy is actually developed that. So then, analog UV scattering communications and PDF and radiance here. And you see, I mean, this is, we see this depending on the values of alpha and beta, it actually, increasing the turbulence. So as you, for example, alpha, increasing alpha, so then PDF is spreading over a wider range and the fading becomes more significant. So that is more or less expected results. As you increase the alpha and beta, so it will actually spread over more and the more, more turbulence. That is what we expect. And then one more result here, and then this is actually what we show is the bandwidth requirement here and the power requirement. So we see depending on the modulation schemes. So if you look at the OK to return to zero modulation here, so then which is OK, which is this one, isn't it? So this one. So if you see this graph here, then power requirement is increases with the duty cycle. So duty cycle is actually, this case is 0.15, this is 0.25. So increase the duty cycle, of course, you require the higher power. And the bandwidth requirement decreasing when you increase the duty cycle. So that's something we can easily understand. And now for PPM and the DPIM, and then the double header PIM, then we see the L value, which is the symbol length. So the number of symbols so increases, the power requirement reduces, of course. However, bandwidth requirement increases. So we see when your L value is the number of symbols, you're increasing that, then obviously you're going downward to the right. So which is you require the higher the bandwidth, and that whereas you actually have reduced the power requirement. So that's what we see. And in terms of the bandwidth requirement, and OK non-return to zero is actually superior. So basically, this, talking about some digital modulations for optical wireless, we quite often using OK, which is very simple, very easy to understand, and more or less it's not, it's not bad, considering all the applications. But of course, there's a few other modulation schemes have been developed. Actually can use, it has own benefits, and then of course it has own disadvantages. So that's the what we have found. Okay, so that's basically what we have done, and our, my conclusion is, so we developed this statistical model first time ever. We presented this model to describe the fluctuation over atmosphere when each scattered path follows the Malaga distribution. And we looked at the trade-off between the optical power and the bandwidth requirement. So, well, this is one small factor one should consider in designing the optical wireless communications. And as I said, the OK non-return to zero requires a minimum bandwidth for a constant data rate. And also we found the PPM for the power requirement outperforms other modulation schemes. But that brings me to the end of my presentation. Thank you very much.
Okay, thank you very much.
Any technical problem there?
Sorry, we turn off the mic. So he will give a question again.
Yeah, Professor, can you please a little bit explain about the UV advantage over VLC?
Well, you know, it's kind of things we can easily transmit a signal over the non-line of sight transmission. I mean, VLC is good, but more or less, you know, it's directional. Although you can support the non-line of sight transmission, but less likely successful. So that's why. But of course, I mean, you know, VLC and some other types of optical wireless communication has its own benefit, pros and cons. So it's not like one is superior to the other, not like that. So we have some, you know, some advantageous applications with the particular types of the optical wireless communications. So that's what I can say. Okay.
One more question, Professor. That in terms of communication performance, is there any difference between VLC and UV?
Sorry, can I have your name, please? Because you didn't introduce yourself.
Oh, sorry, Professor, I'm Sejan.
Oh, okay. From where?
I'm from Pukyong National University.
Okay. Is it Professor Madam just left?
Yeah, yes.
Okay. Sorry. Right.
Yeah.
Well, not. Sorry. What was your question? Sorry, I forgot that.
Actually, I was asking that is there any difference in performance, communication performance in UV and VLC?
Well, not very much so. So in more or less the same. But again, you know, depending on the environment, you know, what environment you're actually using. Okay, so that's the only thing we need to concern about. So sometimes, you know, outdoor or indoor. So you know, you need to consider, you know, what environment you actually, you know, intending to use for the, you know, transmission. So depending on that, so maybe one is better than the other kind of thing. So not exactly overall, you know, the superiority of one particular the communications. So it's difficult to say that.
Okay, thank you.
Okay, thank you. So
Okay.
Actually, I have also one question. So
I can see only your mouth only, Professor Chung. I cannot see your face. Okay,
No.
that is okay.
Okay.
I can see only your mouth.
Yeah. I have one short questions. Okay, when you use medium UV for the scattering, what's the distance? I mean, from the source of the UV and at the receiving side, what's the maximum
Well,
or
it's very-
optimize the distance you assumed?
Well, it's very short distance. I mean, because this is the terrible disadvantage associated with the UV is transmit power, because it's very harmful light, you see. So you cannot use a very large transmit power. So that is a problem. So it's very limited, you know, range we're talking about. But if you're allowed to use, you know, higher power, so then you can increase the distance. Now, so because of this, you know, kind of trade-off between your transmit power and the distance and the the safety. So that is all what we always concern about. So it's not very much long distance we're talking about. So relatively short distance, particularly in indoor communications, is very much prohibited unless you use a very limited power. Is you know, which is standardized by the international, organization. So it's very short distance we're talking about. Yes.
Okay, thank you. As you already mentioned, Professor John, it's a medium UV is very harmful, right? Even maybe you received the scattered UV.
All right.
So I'm wondering about the harmfulness of the transmission community, ultraviolet communication. So
Yeah,
do you
yes.
have any opinion on the fact?
Yeah, I mean, yes, it is harmful. So that's why it's not taking off quickly because these research topics have been around many, many years, but it's not taking off very quickly because of the harmful effect on humans. So that's why, but I mean, in terms of the communication quality, no, sorry, not quality, in terms of the communication aspects, it is useful and interesting, but because of this, safety issue, it's not really picking up quickly. So, well, we don't know exactly, but depending on how you design the UV LED and so on. So maybe in the future, somehow maybe we can have a get around to that. So we may have a very popular applications with the UV. So in the future though. Okay.
Okay. Thank you very much. Any other? Okay, this is the question from the floor. What's the best application areas of the UV communication? So outdoor, right?
Yeah, outdoor.
So what's the application can be applied? Just the outdoor communication instead of wireless communication?
Well, just outdoor wireless communications.
Where we will use. It's just the question from floor.
Who is asking the question?
Okay, you can go to take. Yeah. Okay, I will turn off. Okay. Okay, he will come. Professor Dhananjay want to give questions.
Yes. Hi, Professor. Actually, my question is that what is the best application where we can use this kind of communication medium? For example, outdoor agriculture field, but as you know, the very short range, then where we can implement real time, we can see for the application purpose.
So far, nobody knows. My answer is, simple as that. So, I mean, it's not really envisioned indoors, but mainly outdoor communications. But my guess, is that we may use some vehicle-to-vehicle communications, I think, and also some drone-based communications for various data gathering. So that is what I'm thinking. So in fact, not quite known yet about this application. So that's why it's not really kind of interesting or arouses some much interest from the researchers at the moment.
All right. So Professor Mani, now you can ask your question.
Sir, good morning, sir. This is Dr. Nagamani from University of Hyderabad.
Okay. Yeah, nice to see you. But I cannot see your face, but I can hear your voice very clearly and loudly.
Yeah, I hope you can see me now.
Not yet, though.
Oh.
Well, your video was on before, actually, but it actually turned off for some reasons, but I don't know why.
Yeah,
but hopefully you can turn it on.
Yeah. Sir, my question is that So this one point is health hazard kind of thing indirectly if we are using the agriculture field. So you said that we can use these things agriculture field, but the agriculture is field is producing the food which is directly going to human. So is there indirect effect on the human health if we are using in agriculture field this kind of communication part? Because now agriculture field is growing in IoT applications and other things, and this is the good option for using the monitoring the crop management and all other things kind of thing. So where we can eliminate the human intervention part kind of thing. So if that's my, yeah, my question is clear, sir?
Okay, yes, very clear. Okay, well,
Thank you
I
very
didn't
much.
say, we can use this UV for agricultural applications, but I didn't say that. But having said that, we may think we can use this technology in a limited sense. Okay, which means, as I said, I mean, it's harmful, but we can make it, less harmful, or rather, we make it completely, the no harmful. So by limiting your transmit power, because it's all to do with your power level. So if you keep that at a minimum level of your transmit power, you can use that for that purposes. I believe that we can find many applications, because the thing is, the RF spectrum is becoming congested now. So what is the other option? So where we can see the optical spectrum, just unlicensed and free to use. Okay. And this UV, particularly, unlike other types of the optical wireless communications, this UV can easily go beyond the obstacles. Okay, so, and then for agricultural purposes, maybe you don't have any obstacles or anything more or less line of sight, transmission path. You can have it, but sometimes you can have an endless path. So then you can easily use this UV for those communications. So well, I mean, there's one alternative. It's not absolute, the only alternative. So, but UV is is available here for those applications. It's another option. That's what I could say. Yes.
Yeah, more clearly, just my thought after listening your lecture. One of my thought is that, so normally present the water pollution is more and other thing. So we want to give the good water to the green field kind of thing.
Right.
So in that location, if very harmful germs and other thing, we can utilize this technology to clean the harmful this thing, and then we can produce this. Is it possible? I don't know.
Well, I mean,
if it is harmful,
yeah, I mean, because you should be very careful when you use the UV to kill the germs, and then because to kill because UV, over the UV spectrum you have UVA, UVB, UVC, right? So UVA is mostly 95% of the sun actually having UVA. UVB is about 5%, 6%. Okay, so UVA is a tanning light. UVB is burning light. And UVC is a sterilizing light. Okay.
Right.
So now what do you need? You need to use UVC. So that is very harmful. So in very limited sense, you have to use it. To apply to that killing germs in the water. So that's should be careful.
In a closed container kind of thing, we just can establish the system where the human intervention is not there, and this may be a helpful to with the less cost we can clean the water kind of thing.
Right.
Because the
Right. Yes.
industrial wastage and other thing, that can
Yes.
be, water can be utilized. Water is the very good resource, and
Right.
now scarcity is more kind of. That's my
Right.
thought after listening your lecture.
Yes, very
So
good. So it's very good, very interesting. Again, I mean, I want to emphasize that it should be done in a limited sense.
yes, sir.
So otherwise, we'll have a very adverse effect from that application. So that from that technology. So that's what I want to point out. Yes. Thank you very much. It's a very good question.
Thank you very
Yes.
much, sir. Thank you.
Thank you.
Thank you very much, Dr. Nagamani. It's good for your good question, right? Okay. In Korean time now, over 12 hours. So we have to go for lunch. Thank you very much,
Oh,
Professor.
can I have lunch too over there? Online lunch is available.
Thank you.
Okay, so we will have our next session will start 1:30, and there will be the session, two parallel session will run. So this room one, we have we can connect here, and I will share the room number 306B link here in the over the chat box, as well as we will upload over the website as well. So we are going to start our next session on 1:30 a.m. again. I think now we have 45 minutes only to finish our lunch, right?
Thank you, sir.
So it's on time. Everything is going on time, even though we are, I think, 10 minutes only late. So it's perfectly fine. So thank you very much, Professor.
Thank you. Thank you. Thank you very much.
Yes.
Thank you. Thank you.
Okay. So we will be on. This will be on, right? So let's move it on. So I will go with them. It's very So let's go for lunch. So let me reduce it.
끝해야죠. 나가야 돼. 네. 여기가 끝이에요. 아니요, 어제 어이가 없다니까. 체감이 확 거야, 진짜. 아직까지 아저씨 연락 없어. 왜 저러나 싶을 정도로 연락했다. 속을 공정 몰랐어. 나한테 저런 거 없는데. 그 밑에 직원들 어떻게 있나? 어찌 생각해. 아, 근데 직원한테 뭐 성질 안 되는 것 같던데, 소리치고 그런 거는. 그래도 너무 갈까봐. 소리 쳤으면 지금 주인이 있었겠어요, 계속. 그, 땡 나갈 때 같이 나왔겠지. 약간 그런 거 아니지. 그런 다른 사람이지. 자, 이봐, 잘라야 돼, 이것도. 잘라야 돼. 끝까지 피안 텐데, 잘라야 돼. 빠르게 하면 죽는다. 몇 시간에? 사건 내용에서 예약했고 취소를 당한다고 말씀드렸고요. 네, 그 사이트로 들어가서 보니까 그 수수료에 요청, 공공사한테 요청 못했거든요. 아마 저기 숙소 그러니까 호텔식으로 아마 뭔가 갔을 것 같은데. 서울. 김구지. 네. 뭔가요? 네. 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 아, 그걸 얘기하는 아, 알겠습니다. 제가 그 사인 받으면 일단 제가 외치고 있어가지고 일단 갈게요. 네, 감사합니다. 마이크 테스트, 하나, 둘, 셋. 마이크 1번입니다. 마이크 1번, 하나, 둘, 셋. 하나, 둘, 셋. 하나, 둘, 셋. 네, 주인님, 신호 들어오나요?
신호가 쓰는 거 아니라서 잠시만 대기요.
네. 그 호텔은 저기 소금도 있으면 취소 가능하다고. 해야 그건 좀 좋은데.
마이크 2번 마이크 하나 둘 셋. 하나 둘 셋. 마이크 2번 마이크인가? 하나 둘 셋. 마이크 1번 하나 둘 셋. 뭐라고요? 아예 신호가 안 들어가나요?
그럼 지금 숫자 맞는가요? 지금 한시 반에 지금 시작이잖아요. 아까 안 되죠? 그래서 이만 사람 저희도 혼자고 딴 사람 주는데. 내일이라도 됐나요? 그러면 끝나고 가보던데. 바로 많이 받아요.
I think you. Actually, I'm managing from here also, and I need to go right there. Really? Yes. Yeah. Sorry. So,
Hello, Madhusudan.
hello.
Mr. Tripathi. Hi.
Two minutes. Yeah.
Okay.
You didn't get the second session schedule, right? Who's this? Professor, if you want, we can put the table like this way. Oh, this way. Yeah. Okay. So I can get some reference page too. Yeah. Oh, no. I have shared the chair. What? I have shared the second session link on this chat box. So please take a look. For the session 2, people can be joined this chat box. Okay, this time.
Thank you. How do you do? I am Daegi Kang from Dongsu University. We would like to start a session in the afternoon. The session one about intelligent interface for human. So in this session, there are 7 papers to be presented. So we'll start with the first paper. There is a requirement for upper lip rehabilitation with FES and the exoskeleton. The speaker is Woo Jin Kim from H3.
Hi, my name is Woo Jin. Please give me a second. So, can they see this presentation or?
You need to share.
I need to share?
Share screen.
Share screen, I don't see that.
Yeah, in the Zoom. You have share screen here. And you share the screen.
Screen. Share.
Okay. And you can. I don't like this. Maybe okay. So here, like this.
Okay.
And this.
Small one.
Okay, so I don't know why the.
You need to stop share first and then share again.
Why? Oh, no, that's okay. That's okay.
Maybe they cannot see it.
No, they are watching us.
Do you share?
Yes, they are watching us because we don't mute and so.
It's sharing now.
Sharing now. So you can just remove this, hide the floating control. If you press escape, it will show again.
Thank you. So I'm gonna talk about the requirements for upper limb rehabilitation with FES and exoskeleton. So I'm gonna introduce my project. The name is I Care here. So its objective is to develop a medical device for the at-home rehabilitation. So we are using some sensors and actuators. So as a sensor, we use the EMG, the electromyography function graphy, and the IMU for inertial measurement unit. And also we use the actuators like FES, which stands for the functional electrical stimulator, and also we use exoskeleton robot. So the objective is developing the upper limb rehabilitation system. There are various rehabilitation systems for the lower limbs, but the upper limb is relatively small, and the device should be very sophisticated, so it's more difficult technology on these devices. So we draw the following innovative R&D issues. So before our project, the upper limb rehabilitation is at clinic and also expensive and therapy-centric, and also it is very naive. We treat patients with the open loop rehabilitation, which means it's when we switch on the FES or exoskeleton, it moves like, or it actuates like following the profile predefined before the treatment. But our device will be at home, and the price will be affordable. Sorry.
Little back, so camera will come out.
Sorry.
Yeah, it's now you can speak. Actually,
Okay.
very close, so it's very close. Now you can see.
Thank you very much.
Yeah.
Hello. So at-home device should be affordable price and also patient-centric. So the innovative issue is the versatility and software-based interaction, and not expert use, and also robustness should be guaranteed. And also we want our device to be effective, so they should be customized to the patients, and also we use sensor signal to for the feedback of the patients. So we control the actuators in the closed loop way. So in the middle of these things are our innovation items. I'm going to talk more about the closed loop engineering. So here is the human body, and also there are sensors, so they measure how they work, how they move, and then there is our key algorithm, so impairment assessment and the brain body model, or the skeletal model and the muscle model, something like this. And then we use this information for the shared control logic. So we made some signal to actuate. So actuators and stimulators are the device to actuate the human body. So they can support the movement. So this patient can move more like normal, and they can also train very many times, and they don't be tired so fast, and then they can achieve the more better movement, right? So the objective of this paper is how to specify the requirements. So we first defined our major interested parties. We categorized the parties into 4 groups. The first one is client. Second one is business operators. The third one is users, and the rest one is developers. So the clients means the research funding agency, and also the final confirmation of our research outcomes. So KIAT is kind of industrial funding management in Korea, and the CDTI is the same agency in the Spain. Actually, this project is the bilateral project between the Spain and the Korea. So these two agencies are our clients. And the business operator means the conducting business using the research outcomes. So in our consortium, we have the exosystems, the Korean SME, and they are developing the rehabilitation devices and already have some product for the lower limb, but they are challenging now for the upper limb. And GoGoA is also the SME in Spain. They develop exoskeletons, and exosystems are developing in terms of the FES, the electrical stimulation, but the GoGoA is developing in terms of the exoskeleton, the exo robot. And users, we can easily guess that who is users. The first one is the patient, and the second one is the clinical staff. Users should give us some kind of requirements, the user requirements, and also they will test our product now after we have finished our outcomes. So Busan National University Hospital is in our consortium, so they are trying to acquire the data from the patients, and also they will try the clinical trials after we have finished our prototype. And developers, who actually develop the systems, and the engineers, and maybe testing the device in terms of the functionality. So actually, is our institute, the research institute, and the Tecnaria is some kind of the ICT research institute in Spain, and also IHS. They are the small SME in Spain, and they are developing the electrical circuits, something like that. So all these stakeholders have meeting through the conference call or F2F, face-to-face. So we have drawn our novel requirements here. First, we have drawn the user requirements. So the target body was wrist and elbow. The feasibility, we have divided two types. Function, the first one is mandatory, and the last one is optional. And the user type, the patient, clinical staff, and the distributor. So we have discussion with the face-to-face meeting, and the conference call, and the Google Doc. We used everything we can do, and then we have drawn the 37 user functional requirements here. Actually, this picture is the screenshot of the user requirements with the Google document. We have updated all the time here. And next, we have user requirements now. So we develop these user requirements to the system requirements. Converting to the system requirements, the research institute are working mainly, and we have the following, let's say, about 40 or 50 system requirements here. And from these requirements, we have drawn our architecture of the iCare here. Sorry, iCare is the name of the project. Okay. So I don't want to explain the details of the architecture, but the main role is how to make the cognitive computing model. The computing power is on here, and these are. I'm sorry. These are user, and these are devices, sensors, and actuators. Computing power here. This is the user interface. So I can show what we have done in the next page. This is some progress of our project now, because the paper was written in the middle of this year, and now we have moved on to the next step. So this one is, you cannot see here. This one is the cognitive computing model. So all the computing things are in here. We also use deep learning or something like that, and we have also the neural net accelerators in here, and they are connected to the EMG, IMU, and FES, and also the robotic arm. This is the FES and also EMG sensor. device which was developed by the Tecnalia in Spain. It is the concept is like the electrodes are printed on the flexible circuit, so it can cover the base of the skin here, so they can measure the electrical signal from the muscle, and also they can stimulate the muscles. It's also multi-array sensors, so we can choose which channel we can actuate or measure. And this is the visualizer tool, so it can show us which signal is coming in the real-time manner. And this is our robotic arm, so it is mainly used for the elbow rehabilitation, so they can assist our elbow motion, the flexion and extension. And this part is the user interface. At the first time, we want to use the user interface like tablet PC or the smartphone. So at that time, we are trying to develop the application level, but we have changed our ideas. So now it is working on the web browsers. So there is server, and when we access using the domain, then the web browser can show us the status of our body, and also we can comment to start our rehabilitation training session or something like that. Yes. Okay, but my slide is a little bit left. Yes, I will go fast. So we have some validations also. So we want to use this one on the real human body. So this pulse amplitude and the pulse frequency and the pulse duration is very important. So we have strictly validate our devices, and also we have verified our signals from the EMG and the IMU. Yes, like this. So now we can measure the muscle activations and also the movement of our body. So here is conclusions. We have presented iCare system, so which has the rehabilitation functionalities and for the recovery muscle function. Sorry. And we have specified requirements.
তিনটে 45 থেকে 4টে আমার স্লট, বাট 3:30টার সময় আমাকে অন হতে বলেছে। না, আগে থেকে তো অন হয়ে যায়, যে আগে থেকে তো তুমি লোকের গুলো দেখতে পাচ্ছ। দুটো মোডে চলছে না, মানে ওইখানে কনফারেন্স হলের মধ্যে অনলাইন অফলাইনও চলছে, আবার যারা যারা যেতে পারছে না তাদের জন্য অনলাইন চলছে। দেখো video.
Okay, it's kind of a technical mistake, but I will go on. And I have specified
Hello.
37 user requirements and 52 system requirements. Okay, and I also presented the work in progresses, so our prototyping status and also some validation results. Thank you.
Any questions? So in your system, your system is work in progress, right? So you will not actually apply your system to human head?
Actually, the actuation part is a little bit dangerous for the patients. So we only have used for the patients the sensing part. So we have measured using our devices from the patients, but we don't try to actuate now.
Okay, thank you.
Thank you.
This work is belong at the IoT department lab or which department actually?
Actually, it's cognitive engineering.
Cognitive.
Yes, it's for the stroke patients. So we are interested in the cognitive function of both humans. So, yeah, we are in the department. Thank you.
How many sensors you accept in your system?
Okay, for IMU, we attached link by link. So hand and the forearm and the upper arm. So we have the motion now. And the EMG, we use it for the main muscles. So for the forearm, we attach 4 EMGs and the 2 EMGs for the upper arm. Okay, thank you very much.
Any question from the online audience?
Yeah, I see. Yeah, that's good.
Oh.
So you can see. Is there any question from online audience? Please ask any question if you have. Professor Mani or anybody has any question? Any question?
I think.
Yes, he is going to answer. Actually, they texted.
Okay. Through texting. Can I see the texting?
Yeah, you can see here. Okay, see, no question.
Sir, am I audible?
Yes, we can hear you.
Yeah. Thank you for presentation.
Right.
My question is that, so this robotic arm you're working, but are you taking every movement of human hand? Am I audible?
Yes.
Am I audible?
Yeah, we can hear. Go again, one more time.
Yeah, the robotic arm part. Our human arm can move, for example, fingers and other thing. So if we have if we are using this, I'll just see. Yeah, we are using the arm kind of thing, so that our arm can move like this, right? So this will be, and the finger can be moved like this. These kind of movements can we do presently with the system? See, multi-level, the movement, a robotic arm.
Yes.
Yes, robotic arm. So presently, your arm is able to pick some weights kind of thing, or the movements. Rehabilitation means it's a, for example, you just trying to exercise purpose you are using kind of thing, right?
Oh.
So normal human arm can be have a multiple level of movements with the multi-directional kind of thing. Present your work, how you are going to bring these kind of movements.
Okay, for the acute phase patients, we are using the baseline movement, but when they recovered a little bit and going to the chronic phase, they not just the baseline movement, but also they can assist the patient's intent. Is that the right answers? I don't know. Okay.
All right. So, okay, thank you very much for your presentation.
Thank you.
So, Professor Khan, now you take over for the next.
Okay, I'm sorry that you are a little bit behind the time. The next speaker is, could you bring the syllabus? So that, thank you. Yeah, that one. I forgot to bring this. Next speaker is Dr. Ashutosh Mishra, and he's talking about IHCI-based in-cabin monitoring system for evaluation situation with occupant facial anonymization. Thank you. You don't have to be in rush, and if we are about like 3 minutes at the deadline, I'm before you. Right? You can handle it. Yeah. Thank you, Professor. Good afternoon, all respected session chair, co-chair, dear participants, and our entire IHCI organizing committee. My name is Ashutosh Mishra, and this is my presentation on HCI-based in-cabin monitoring system for irregular situation.
Yeah, I'm sorry, my system got disconnected. Sorry.
Occupant facial anonymization. The authors are Ashutosh Mishra, Jakwang Chha, and Shriho Kim from Yonsei University of Yonsei Institute of Convergence Technology, Yonsei University, South Korea. So, in this paper, I have worked about the in-cabin monitoring system for irregular situation, and especially to maintain the privacy while monitoring in-cabin of the fully autonomous vehicle.
Yeah. Yes, so we need to share it on Zoom. This one, no, where is PPT? This one, right? No, it's okay, right? F5? Yeah. Yes, go ahead.
So in this presentation, I will first introduce about my work regarding the motivation of the work, the requirement, and the bottlenecks. And then I will try to discuss about the background theory and fundamentals and the recent development in terms of brief literature survey. And then I will explain about my proposed face anonymized in-cabin monitoring system. And then I will show the results and discuss them. And according to that, finally, I will conclude the findings of the paper and tell about the future scope of this work. So as we know that most of the renowned and reputed organizations in autonomous vehicle like the NHTSA and SAE, they have said that there are 6 levels of autonomy in the autonomous vehicle. So I'm talking about the fully autonomous system. So we can take the level 4 or level 5 vehicle. Level 4 are the autonomous system, autonomous vehicles up to certain limitation. They can drive for under certain constraint only, but level 5 vehicles are fully autonomous vehicles. So in that view, according to the NHTSA and SAE, the level 5 vehicle does not have any human intervention for the driving task. So all the occupants inside the vehicle will be the passenger. Now the condition occurs that if there is no in charge in that vehicle, so there might be problem with the safety and security. So to handle these problems, we need to monitor the in-cabin of the vehicle, like for safety related to the accidental case, related to the some elderly patient or some child is there. So we have to look for them, and related to the security, we have to watch, we have to monitor for in avoiding the condition of any violence, any threat, or we have to take about the privacy issue. So we need to monitor our vehicle. But again, the problem is, if we are going to monitor, then we can think of monitoring in cabin, locally, like inside the vehicle, and we have to share that data to the data center, because these vehicles are connected vehicles. So we have to look for the monitoring on the cloud as well. So we have to share these data, the in-cabin related data, to the cloud as well for the data center and further monitoring aspects. But here occurs one problem related to the personal privacy, because we are going to share the facial information of each and every occupant there. So if we are going to share, there will be a threat regarding the personal facial information. There is one way so that we can do that. We can filter out the facial information, or we can provide some patch, apply some kind of blurring image, but that will again have the problem with the facial features, because on the data center and the control room, we will use that facial feature to monitor the intent or behavior of the occupant. Right, as we can see in the figure, that if there is a face without any facial feature, facial information will be lost and we cannot do anything. But again, if we are sharing the facial information with exact face, there will be threat towards the personal information and security threat. In my work, I have given solution for this. Before going to the proposed system, I will try to explain briefly about the background and the recent development. So in 2004, Blange et al. Actually talk about the face swapping technique, and they applied the morphable model. But these techniques are manual, so they cannot be applied in the intelligent system. But in 2017, Zhang et al. Suggested to use the machine learning technique so that the face swapping can be done intelligently and autonomously. But these were only the preliminary studies using SVM classifier for face swapping. Then in 2018, Narkin et al. Utilized the fully convolution network for segmentation and swapping of the face. But problem with that method is it was not end-to-end trainable. It required some special attention for the occlusion, because they use only segmentation for the facial swapping. So if any face is occluded by hand, or if there is something already occluded to that face, it creates some problem. Again in 2018, Nasume et al. Suggested the region separative generative adversarial network. We already know that GANs are nowadays taking popularity because they are very good in kind of visual data. So the region separative generative adversarial network was very good and very intelligent method for facial swapping for end-to-end training. But it was related only to the facial swapping of images. It was not for the video. In video, there were some problems. I will talk about them. So in 2018, only Perswan et al. Presented a gain-based approach named as the deepfake, and that was related to the video. That was the first work when they published a public domain database as well for face swapping techniques. Then in 2019, Narkin et al. Again proposed one interesting technique, that is FS gain, face swapping generative adversarial network. That technique was having beauty of face swapping as well as face reenactment. We will see in further slides that what is face swapping and what is the reenactment. But that method was really very good, and we have used this approach in our as a baseline in our proposed system. So it was having capability of swapping as well as reenactment. So face swapping is basically transformation of a source phase to the target phase in such a way it can be seamlessly transformed. While it only is the phase swapping, but if any video is there, if any facial movement is going on, so we require reenactment of that phase, the swap phase. But if we are only using the phase swapping technique, reenactment may suffer because reenactment has not taken care in phase swapping technique. So in FS gain, they have used phase swapping and phase reenactment. Reenactment is actually the swapping of the face in such a way that movement of the facial expression can also be look into the similar manner. So as we can see in first figure number 3, the source image was of Xi Jinping and the target image was taken from the video of Obama, and the face was swapped. So in the middle, we can see the result was after the face swapping, but we can see because of the reenactment effect is not taken care, so we cannot see the exact emotion or intention on the swapped image. But in the figure 4, reenactment has been taken care, so we can see the middle face is reenacted face. It is looking similar to the target face, but swapped with the source image. So actually the FS gain is having multiple generator networks like the as shown in figure 5, and they have basically 3 steps. First one is reenactment and segmentation, second one is imprinting, and third one is blending. So the first generator is GR, which is to estimate the reenacted face FR and its segmentation SR. And GS estimate the face and hair segmentation mask ST for the target image IT. Here the imprinting generator GC is used for the missing part of the face which was reenacted as the FR transpose, and based on that ST to estimate the complete reenacted face FC. And finally they applied blending to mix the target face with the source face, as well as the reenactment and the surroundings are matching. So the blending generator GB blends FC and FT using segmentation mask ST. So what they did, they have used the different position on the 2D position on the source face and try to reenact the target face accordingly. And for that they use segmentation of hair, segmentation of face, and then try to imprint the reenacted face further so that the missing part can be taken care of properly. And finally they try to blend it so that the exactitude can be achieved. We will see what kind of exactitude I am talking about, because as I explained earlier that in my task I require the facial anonymization, like I require face swapping, but with the fact that I require facial information as well, because finally I have to take care of the emotion monitoring or behavior or intent monitoring kind of thing, for which facial information are very much important. So these are the performance results for the proposed FS gain technique by the Narkin et al. We can see it was outperforming the previous techniques very well. This is my facial anonymization in cabin monitoring system, and in the flow chart we can see that the first, the occupant in FAV cabin will be captured, the visual data like the image and video, it will be captured from the FAV cabin for monitoring in cabin. Then if we require local monitoring, then we need not to go further. But if we require monitoring on the cloud-based system from the data center and control unit, then we require to detect the occupant And we require to monitor the occupant detection intent and behavior, and for that we require to swap the face, and we require reenacted face as well. So we can see we require this portion, facial anonymization, which is in between the block. So after facial anonymization, we can do the further analysis at the data center for monitoring tasks. So it will look like this. There will be the occupant, which is monitored by the surveillance camera, but the real image of the real face of the occupant will be anonymized by using the FS gain technique and the proposed system, and then unanonymous face will be generated for further monitoring of intent and emotion and sent to the cloud, sent to the data center using cloud techniques. So in our system, we have focused on the facial anonymization in terms of gender and in terms of the facial look, because we have seen that the Eastern faces and Western faces are different, and gender-wise also male and female version of the faces are different. So if we are going to use the source image of some other gender to implement it on the target image of some other person, it will have some problem. We will see in the result. So in my proposed system, I have taken care of the gender and look. For this task, I have considered the Eastern and Western look, and for male and female gender. So the steps are capturing in-cabin visual data from the in-cabin of fully autonomous vehicle, and then face anonymization using the face gain technique, and then send the data to the data center, and finally to monitor the behavior and intent of the FAV occupants. So now these are the results. First, these are the source faces which I have generated artificially. Means, yeah, one more thing. If we are transferring the real face as a source face to the target face, then there will be again the problem, because it will be fake. Suppose in previous slide, we have seen the face of Xi Jinping was transposed upon the face of Obama. So it may create some mistake or some problem that some person can be threat by his or her personal identity. In that means, so I have taken care of this as well to maintain the privacy, and I have used only the AI generated face. So these faces are not the real face of any human on the earth, because these faces are generated intelligently using AI technique, using gain. So I have considered two cases, the Eastern, as I have already told, that Eastern look and Western look. And for the Eastern look also, I have taken care for the female and male face. And similarly for Western case also, female and male face. And I have applied these source images on these target images to see the effect. So there are two figures. The first figure is the target face of Western male and having sad emotion, and the second image is the target Eastern male and female faces with shocking emotion. And these are the results. After swapping, the bottoms are the results corresponding to each source images. So we can see that if we are transforming the face of a male with the female, results are not good. And if we are using the different look, like the target image is of the Western male, so we can see the best result is obtained only with the fourth, which is shown by the green circle. If we are using Western face for male as a source for transforming and face swapping, so the best result will be obtained only for the fourth. Similarly, we can see for this, because here Eastern male and female faces are there, so we can see if the face has been swapped from the for the male from the eastern face, the results are good, and for the male for the eastern face, the results are good. Other than that, the results are not so good. And the good results are shown in the green circle. Again, this is the data set captured by our own lab. This is our own data set, but we have just masked the faces to maintain the privacy of the volunteers. So there are three images we have used for this experiment. So the results, the upper result is corresponding to the source image of the female face, and the lower result is corresponding to the source image of the male face having eastern lobe. Now we can see again the results are better when we have considered the swapping of male face with male source image while considering female face with the female source image. Similarly, we can see if we have used, because the volunteers are the eastern look face, so if we have changed with the western faces, the results were not so good. So finally, the findings of this approach is that it is very good novel approach for HCI based in-cabin monitoring of fully autonomous vehicle, because it maintains the privacy of the occupants while it is rendering good result for intent and emotion or behavior monitoring, because it is important, as I have already discussed, that there is no in charge inside the vehicle. It is the important thing. We have to look care of the in-cabin monitoring, but we have to maintain the privacy as well. And other finding was, if we are transforming with the look and gender wise, then results are good. And the important thing is that if you are taking the source images having AI generated faces, so again there will not be any kind of personal privacy breach kind of thing. In future, we can use more advanced deep learning model to monitor more important in-cabin monitoring tasks, like the irregular situation which may happen inside the cabin if there is some violence, some threat regarding teasing or a kind of abusive task. So we can monitor for these kind of situations as well. These are the references, key references in my work. Thank you. Thank you for paying your attention.
Okay, I'm wondering if any question from the
Sure. Yeah, sure.
Okay, that to monitoring the emotion from the image or the video movie.
Yes.
So except that maybe there are several other ways, right?
Yeah.
For example, using brainwave or others.
Yeah.
So what's the strong point of the video capture emotion monitoring systems?
Yeah, because for brainwave, like I'm talking about the autonomous vehicle. So for the brainwave, we require cap or kind of thing to wear. But as we are talking about the personal vehicle or the transport vehicle, it is quite difficult to wear the helmet kind of thing or the different 12 lead or kind of emotive sensors or anything to generate the brain waves. But if we are using the simple surveillance camera, it will be very easier. That is the beauty of it.
Actually, on the vehicle is
Yeah.
true.
So
yeah, when we move outside.
Exactly. In that way, I think if you are using the brainwave signal, that may result very good. But my application is for the autonomous vehicle. So in autonomous vehicle, it will be difficult to wear the cap.
So are there any questions from the online users?
Sir, one question. You have taken, thank you, sir. Your paper was good, the good work. My question is, if you are taking the gender faces and artificial generated gender faces, so normally if we change the haircut kind of thing, sometimes even that variation we can specifically see that the haircut may give sometimes female face also as a male face kind of. Have you tried that kind of situation? So
Sorry,
you are
ma'am.
generating the artificial faces kind of for your work.
Pardon,
So you
please,
are,
ma'am. Can you repeat your question? I cannot hear you properly.
sir, am I audible?
You're audible, but your voice is noisy, a bit noisy.
Oh.
So it was about
Can you repeat?
gender faces, right?
Yeah, you
Am
are
I
talking.
audible now? Is it
Yeah.
clear?
Yeah, you are talking about the gender.
The gender specific faces you are generating with using AI techniques.
Yes, yes, yes.
So in that context, have you tried if change of hair cutting, hairstyle kind of thing, is it possible to identify kind of thing? See, you are taking a various features to discriminate between the gender specific characteristics.
No, no, no. Actually, I am looking about the emotion and facial information only. I said that using exact gender and exact look. So, because I'm going to anonymize the face, and for that I require the exactitude. What I have talked earlier, that the exactitude should be there on the face, because we are going to reenact that face, but that face is not real. It is now anonymized. So for anonymization, I suggested that if you are looking for gender as well, then it will be better result, because we can finally see the exactitude on the face. Are you getting my point? I'm talking about if, as I have shown in my results as well, that if I am just transferring the male face on some female face, so it cannot be reenacted so properly that we can further use it as the input to monitor the emotion or behavior of the occupant.
Okay, okay, okay. Thank you.
Thank you.
Thank you very much.
Thank you.
So we are a little bit. Tata, could you please yeah, your USB? We are a little bit behind the time. 30 June, right? So the next speaker is Arya Consultant from Tonghu University about a novel diminished smooth Allen loss model. We begin, please. So do you know how to use Zoom, right?
Yeah, but the last time I made the video, so can I just play the video or I will make
Can you what?
play the video?
So do you want to? Yeah, you can use USB. Your USB.
I can copy the video.
What?
I didn't copy the video.
Okay.
Did yes, my channel.
Hmm?
Yeah, I upload the video to the.
Yeah, there are so many of these, right? So yeah, you can copy. So copy to some. We make some folder.
No, I can copy the video from my previous.
So
I need to download.
Download. Okay. We don't have much time.
Let's duly maintain that.
On the screen. We need this. Is it? Sure. You gotta show first. Professor John, can you see the problem?
Good afternoon, ladies and gentlemen. Sorry for the delay. My name is Arif Ramasutanto, and I'm from Tungsoo University. And this is my paper called A Novel Release Model One Loss Model with Generative Social Network. And this is the outline of my presentation. I'm starting with the introduction, moving on to motivation, related work, proposed method, result, then summary, and then ending with difference. In the deep learning field, image to image translation is one of the topic in that field, and pix to pix is the one that do the image to image translation with conditional generative adversarial network. So as the previous presenter has mentioned about GAN, so I will not explain it anymore. And in the fix-to-fix, we add the L1 loss for the in the generator part during training process. And this is the process of fix-to-fix in the figure 1. We are in the process. We need the input from an input label from, and then through the process they will generate an image that is correspond to the label that was inputted. So our motivation is because of, as we know, the loss function plays a key role model in the performance of the model. So we want to choose the right loss function so that it can help the model to learn how to focus on the correct set of features in the data to achieve optimal and faster conversion. And this figure 2 is an experiment from a paper called image loss for the image restoration with neural network. The orange plot corresponds to when a network is first trained with the L1 loss first and then trained again with L2 loss. And the blue one corresponds to when a network is trained with L2 loss first and then trained again with L1 loss. And as we can see in the figure, the L1 loss will make the loss decrease faster compared to L2, and L2 will stuck in the local minimum. And as we can see from this experiment, the alternate loss function is similar to the smooth L1 loss function, which in this case is as shown in the equation below. If the X value is lower than 1, the smooth L1 loss will use the top equation, which is L2. And if the X value is higher than 1, it will use the bottom equation, which is L1. And the X here is the target, the difference between the target and the predicted value. So it can be said that smooth L1 loss is combining the advantage of L1 and L2 loss, which is robust to outlier and stable. And as we shown in the figure 3 here, I'm sorry. Yeah, like in the previous video, the smooth L1 loss is highly dependent on the beta or the threshold that is usually fixed at 1. And this figure shows that if you reduce if you set the threshold to lower value, it will have higher gradient, like in the figure 3b. With the higher gradient, you can like get a faster rate of convergence. And this is another method, related work, that there are other methods that modify the threshold in the smooth L1 loss during the training. Their method is they use the running mean and variance. And first they get the mean. They get the mean of a mini batch as shown here, and this is the variance of a mini batch. And they update the running mean and variance using momentum. And then after they have the running mean and running variance, they calculate this portion. They calculate the difference between running mean and running variance. And they choose the minimum between the calculation with beta heads. Beta head here, they fix it to 0.11. And which one is the higher between 0 and the result of this, they will use that as the new threshold. So beta head here is the clipping because they mentioned that the value of mean is not stable during training, so that's why they implement clipping. And another method using the that change the threshold is this loss. Is this method called dynamic smooth L1 loss, and I will explain about the part about the modifying the threshold. So because they use this in the object detection, so the algorithm they use the regression label. So the regression they populate the regression labels into a set, and then after C iteration, they will update the threshold by getting the median of that set, and they choose like the k smallest value of the median. In that experiment, the k they use several number of k. So for our proposed method, we want to modify the threshold of smooth L1 loss, and as we can see in the previous method, that using the we do not want to depend on the data distribution, because as we can see in the previous method, there are some difficulties with the data distribution, and we want to alternate between L1 and L2 loss. So for our proposed method, we decrease the beta or threshold after each epoch with a fixed value or a step. And we get the step value is by dividing 1 with number of epoch. And then we subtract the old threshold with the step. And then this is, yeah. And this is the illustration of our proposed method. And this is the figure of the smooth L1, where is when it's divided by beta. So this side will use L1 and this side will use L2. So in our proposed method, we move the threshold. So and then the L1, the boundary between L1 and L2 is also moved. And this is the result of our experiment. We are using we did the experiment on text effect dataset. And as we, yeah, our method generate less artifact compared to the other method, because as you can see in the other method, they have some residue of the X value. Because in this text effect dataset is this is a style transfer, like text effect transfer. So we want to get this raw text effect with the target style X. And we also did our experiment with other dataset, which is the package dataset. And this is another our experiment with the cityscape dataset. And as we can see here, our result often outperform the other method in the three datasets. So in summary, we are proposing a novel method on how to modifying the smooth L1 loss. And then our method can help the model to learn better feature representation. And also the experiment results show the effectiveness of our method. And this is the reference that we use. Yeah, thank you for your attention and time. there any question?
Any question from the online participant? So let me ask you one question. So in your system, you add regularization mechanism to the definition. So actually, they do have a regularization mechanism, right? Like errors, right? So in errors, you try to move the threshold, right? Threshold. So I'm wondering if you have tried that with the electron map. What I'm saying is you have error loss, L2 right? But if you combine the error loss and L2, there will be electric net, right?
Yes.
Did you try the electric net? Did you try to diminish the interval for the electric net?
The elastic net?
The elastic
net, I think doesn't have the difference between the L1 and L2. They use it at the same time. L1.
Oh, right, because you want to need to do, you basically, in the beginning, you start with the mixture of L and L2, right? Like L1 and L2 and L1, right? You assume the L1 loss actually is a mixture of L and L.
The L1, the small L1 loss. If the
L1 loss and L2.
Yeah. So it's only one loss using it.
So it would be interesting if you add more like L3 or you try to find ways and other ways is good thing. Okay, thank you. So the next speaker is sorry, mispronounced about fault identification of multi-level gear defects using adaptive noise control and the genetic algorithm.
Unplug this. Okay.
Are you familiar with using Zoom? I'm comfortable using Zoom.
Yeah, I need to open the PC.
You need that?
No. I just want to open my presentation in the UAV. Yeah. But that is so, Professor. I just a full screen. Yes, sir. I need to say I cannot do that.
So you said you can. You said you can. So you don't like this?
No. I want to present. I'll share. Okay, but
yeah,
I cannot share the presentation.
Oh, I see. So, yeah, that's why I asked you about it. Okay, so it's a nagging screen, it's still there. So
yeah, good afternoon, Professor and my colleagues. I would like to present my paper as the first identification of multi-level defects using electronic control and genetic algorithm. This outline of my presentation. For motivation, the gearbox usually work in a hard condition, and gearbox fault diagnosis based on vibration signal is very important for early detection. We can see in this slide, we can see in the figure 2, there is the frequency spectrum of the perfect gearbox, the vibration signal obtained from the normal condition, and the sideband frequency, the sideband frequency occur will appear whenever the force occur in the fourth year. We can see in the it can be seen in the figure 3. Moreover, the challenge and difficulty for the gearbox fault diagnosis because of the noise. The noise come from many sources as exit in the vibration signal, and for the multi-level gate effects, they have same similar behavior. Relay work. For relay work, we consider signals processing path and feature engineering path. Few recent decades, many enhanced signal processing was applied for highlight fault related component, like such as Fourier transform, inverse transform, and so on. However, they cannot identify the multi-level gate effects gearbox system. Therefore, we apply the adaptive noise control for significantly reduced noise in the vibration signal, whereas preserving the original gearbox force-related component in it. In order, feature engineering selection path is also very important. So GA genetic algorithm implement the heuristic search algorithm on the original feature pool to select the most relevant and discriminative feature related to multi-level effects. Then GA draw the attention for this study. The proposed methods, the figure 5 show the function block diagram of the proposed method. We will go into each section, each module. For the adaptive noise control, the figure 6 shows the function block diagram of the adaptive noise control module. It contains 3 main functions. Firstly, generating the adjustable Gauss reference noise signal with the formula 2, formula 3, and then construction of the adaptive noise filter, and finally optimization process to implement the optimization process to select the optimized subband on the output of the adaptive noise control. The feature extraction. The output of the adaptive noise control module then used to extract to 18 statistical feature parameter in the time and frequency domain to configure the feature pool. The feature pool configuration is shown in the table 1. For the genetic algorithm with feature selection, the genetic algorithm with the optimal subband optimal feature based on the class Y parameter. Class Y parameter is calculated by quotient of the Euclid distance between two feature from two class and two feature from in the same class is formulated in the formula 6, and the visualization of the calculation for class Y parameter is shown in figure 7a. The figure 7b show the flow chart of the GA-based feature selection. We can see in the figure 7b. For the KNN, K-nearest neighbor is used for classify the optimal feature, the most discriminating feature output from genetic algorithm method to achieve the classify for six category. dataset result and discussion. For the dataset description is shown detailed in the table 2 and the figure 9. We can see more detail in the table 2 and figure 9. We have said 5 level of the multi-level verification, and one case is perfect gear. The result and discussion. In the figure 10, we can see that figure 10 show the effectiveness of the active noise control. It shows the frequency spectrum from the input and output of adaptive noise control module. We can see in the figure the noise between two consecutive sideband frequency is mostly reduced in the output of the active noise control. You can see that is a green circle in the input, and here is a significantly remove the noise between two consecutive sideband. And whereas keep original, the fourth relate informative component is the sideband frequency and massive frequency and its harmonic. For the GA, we apply genetic algorithm and we achieve the optimal subset of the most discriminative for feature. That has F9 square mean root and F17 power spectral density, and we use we draw the 2D visualization of the SIG class of the sample of own SIG class based on two most discrete for feature. Then we can see in the figure 11. We can see mostly the class as a separately the sample from same class as close to each other, and the sample from different class as separate from each other. So it is the clear the good for the it is good for the KNN classifier to classify the sample based on the most discriminative feature, and we achieved the result is 97.78% in average accuracy. To verify our method, we also compare our method with our proposed method with the previous report methods, approach 1 to approach 4, and we achieve our method as outperform the result. It can be seen clear in the table 3. A summary in this paper, the new sensitive fault identification method for multi-level verification is proposed. It's combined active noise control, genetic algorithm, and k-nearest neighbor for classification. Whereas the active noise control help for reduce noise, and the genetic algorithm help for select the most discriminant for feature subset. So by experiment, our method achieve the highest average fault classification result is around 98% in comparison with the conventional approach. For the future work, we will apply our proposed method for multi-level verification system in a very speed condition and the reference. And thank you very much for listening.
Any question?
Can you tell me what kind of sensor you
We using the vibration sensor accelerator, yeah, to determine the vibration capability. Yes.
Any question from the online participants? So, hold on. In the final result, you compare with GAKN and your method is GAKN and the other method like SVN full features, independent component analysis with KNN,
Yeah, independent.
PCA with KNN.
Yeah, PCA.
And the
Principal component analysis.
Yeah, yeah. So, and linear different analysis with KN, right?
Yep.
So why don't you try with ICA, PCA, LDA, and GA? Yeah, actually, you are using GA to do the feature selection, which is the dimension reduction, right?
Yeah.
So why don't you use like SVM instead?
I'm sorry.
Or instead of KN?
Why do not use?
Yeah, SVM.
Because
SVM or something like that.
Yeah. Yes, thank you very much. Because KN is very simple and easy for calculation, and just use KN, we also achieve the good result.
How many features have you chosen and how many instances in the final?
Yeah, for the feature extraction, we just do 18 features. 18. Yeah, and by the genetic algorithm, we achieve the two most native features.
How many instances? Feature the 18.
Yes.
18. How many instances? How many examples?
Sample for the 1/4 is 100 sample.
100 sample.
Yeah. So totally 600 sample. 600 samples.
600 samples.
In total.
Yeah, I think that might be for SVM, then might not be big number. So it doesn't probably it will not take a long time. So you perhaps could. I recommend you try GA with you replace KNN with SVM.
Yeah.
Then perhaps you have some interaction. I don't know. So did you do some cross-fold validation, average classification, right? So you actually run several times and you got the mean value, average value, right?
Yeah.
Okay. Thank you.
Yes, thank you.
So next speaker is remove that. Yes. The next speaker is Nguyen Mai Hong Long from Bogyong University, a prototype, correct?
Yes.
Yeah, a prototype wristwatch device for monitoring vital signs using multi-wavelength plethysmography sensors. Okay.
Thank you, Professor. Good evening, Professor and everyone. This is my presentation. First, I will introduce myself. I'm Nima Halong. I'm from Kukyong University in Busan, South Korea. And today I will present my paper, with title of prototype response device for monitoring vital signs using multi-wavelength photoplethysmography sensor. And this is my outline content. First, I will introduce my motivation and this related work. Next, our proposed methods and our results. And finally, I summarize and do the work. That's my introduction today. And first, I would like to explain some terminology with work. Vital sign means some essential health status condition which we can use to check our health. It's including information, body temperature, pulse rate, respiration, blood pressure, and so on. And which new photoplethysmography method we can use to measure vital sign, and it's quite popular today. Why is so popular and we keep work with this method? Because it's also can use for many purposes. And from previous work, in order to measure some vital sign like blood pressure, we need some techniques like PTT, mean pulse resistance test, and it requires us need to measure two positions, and it's not good. So a multi-wavelength PTT is another new technique to reduce just 6 measure in single cell. And if some people recently focused on the single site, which multi-wavelength can use to measure vital sign. And also in our lab, regular time, we have focused on some techniques like IBC and TBC, and we focus on the wearable. So we mainly focus on intravenous artery and radio artery. And this some prototype circuit has worked in our lab. However, almost the previous work just focused on the methods and technical, and not focused on the design sensor and the full wearable system. So it is the reason why we will make the prototype for the wearable. And this another work they design for the PVC just single position on radio artery use 4 wavelength, and we also based on this research for in our design system. And this our proposal based on the inspired from traditional Chinese medicine. We also focus 3 points on along radio artery to monitoring and collect pulse sensor for monitoring health system here. And also we use visible and near infrared wavelength for our system, which including 2 visible line in 640 and 530 in, and 2 near infrared including 940 and 850. And this is the proposal of our system, which including main feature. First is array of 3 sensor, optical sensor, and we have interface with the analog coordinate, namely AFE 4900, with very high ultra low power integrated IC, which help us can control well the optical sensor. And for collect data, we need to use the system with MCU named MSP 432. It's a 32-bit MCU. And we also employ a module Bluetooth version 4.2. That's very flexible MCU for Bluetooth communication and very suitable for IoT context. And here is the image of our system design, including the optical design sensor and the system after we have fabricated. And in the demonstrate our system work, we intend to take the measure blood pressure by all the techniques in single side, you reflective full detection time or PTT. And this, in order to measure PTT, we will collect the time transition between the systolic peak and the reflective wave in, as you can see on the image. However, because the size of signal is distorted, so it's better we can use the second derivative of PVC, and it will be robust to estimate reflective PTT. And on the slide, you can see the formula to estimate the systolic blood pressure and diastolic blood pressure. For in this formula, in order to estimate blood pressure, we need to some calibration to estimate the coefficient, including KE, KB, KC. And is the Broxer model for collect data for changing model and calibration. In my model, we will have 7 steps to collect data, including repeated Vassava maneuver to increase blood pressure and in rest condition. And on a stay, we will happen in 10 minutes. And we measure G time and gas average data to get the calibration font for changing our model. Also, we take some experiment to find the which position could one upon the best position for collect data. And from the first pilot research, we collect several subjects and we go into the conclusion that the position in quantum is the best position to collect data. Also, the near effect in 850 and 940 is the best position to best wavelength for collect data. As some previous research has argued. And on the slide, you can see some typical signal we have collected from quant phone, one phone, and G phone. And this table to express the AC over DC ratio between PVC signal. And as you can see here, for 940 is the best for collect. And after changing model, it our research for estimate systolic blood pressure and diastolic blood pressure. And the green font is for diastolic blood pressure and response for systolic pressure, and the cross for our estimation. And we can see for diastolic is a little lower accuracy compared to estimate systolic pressure.
And also in our investigation, we also discovered one a new effect happen in the radioactivity. We name it for inverse phase because as you can see on the slide, there's the inverse signal happen between the two PPZ signal. It's a new signal we discover, and we have more in conclusion. So in summary, in this research, we have made a wearable device using multi-valent PDC and multi-location for monitoring vital signs. And we also confirm that the one position in body is the best place for collect heart rate spool. And with the amyloid reflective puncture system, we can estimate blood pressure well. However, the error is quite high, over 10 milli hydro. So, and also we discover a new effect, namely for inverse phase. So we can use it for a new direction for a new research. So in how future work, yeah, we can improve to blood pressure accuracy estimation and take advantage of inverse phase for new research. Yeah, thank you for your attention.
Any questions? Any questions from the online participants? Okay, so because due to we only have about 20 minutes left, so if you have further questions, I recommend to you can apply or send in an email. Okay, thank you.
Thank you.
Next speaker is.
Yeah.
Next speaker is Nu Dao Mai from also Kogyang National University.
Yes.
Thank you. So he's talking about detection using multi-channel custom design easy system and multiple variants of knowledge. What my doing is
Yes.
Yes. Make this. Okay.
So, good afternoon, everyone. My name is Mike Zhou from Kogyang National University. So, today, on behalf of our team, so I give my presentation about deception detection using a multi-channel custom design, easy system, and multiple variants of neural network. So my presentation will be 5-minute session, lie detection using easy, then fabrication of 8-channel custom design easy headset, and the third session is proposed method, and then I want to show our results, and the final session is about reference. So in the first session, I give some information about EASY and BCI. So EASY is to estimate changes in neurophysiological activity to estimate changes in neurophysiological activity using electrodes placed on the scrap surface and is associated with external stimuli and or with the performance of specific tasks is shown in figure 1. And about BCI is a hardware and software communication system to enable humans to interact with the external world by using control signals from easy activity without speaking or moving. And here figure 2 shows some various fields when applied besides like clinical trials, robot controlling, or gaming, or emotion recognition. So, and this slide I will show some information about lie detection, with its purpose is to identify the truth perceived and covered by others. And the test for lie detection is the concealed information test. And we have some methods used for CIT test based on skin conductivity or body temperature, eye behavior, pupil size, or voice or brain activities. And among them, the technique based on easy signals is way because it's higher compatible and it's natural with unbiased evaluation and high accuracy. So in the next session, I will show some information about our fabrication of 8-channel custom design easy headset. And a figure 4 show our easy headset diagram with 5 main parts like a cap with active to dry sensors, amplifiers with filter, analog to digital converter, and microcontroller for controlling process, and the final part is UART for communication between computer and our headset. And the figure 5 show more detail about our conditioning circuit of the 8-channel easy headset. So in this slide, I will show some important features of our headset. It has lightweight and small size, just a 6 centimeter and 6 centimeter. It has 8 active channels and 1 reference channel and 1 bias channel. Here we use a dry active sensor from Cognionic company, and device case is cell-made and fabricated with 3D printer. And the figure 6 and 7 show more detail about our circuit. So in this session, I will show our proposed method, and figure 8 shows our the block diagram of the proposed method. After conducting experiments, we have some main stages like we are pre-processing with filter and segmentation, and then applies 11 feature ejection methods to get valuable features. And the final session is we apply variants of neural network for classification. So, and about experimental participants, we have 5 volunteers, aged from 24 to 40, with 3 males and 2 females, or in stable physical and mental health, especially do not have visible defects and eye-related diseases. We have stimulus with 30 short videos, each lasts 44 seconds, and selected pictures is celebrities, relatives, past advertisements, movies, or a famous event. And about measuring location, we have 8 electrodes for active channels, and FCS is the reference electrode, and is shown in figure 9, and figure 10 show our protocol of stimuli with total 30 channels. And so let's go into details about important parts like data processing is to reduce the adverse effects of signals artifacts like power line noise, cable movements, body movements, and we use bandpass filter between 0.5 to 60 Hz and notch filter to eliminate 50 Hz power line noise and a sliding window of 128 lengths with an overlap rate 50% to segment the dataset is shown in figure 11. And about filtration, we have some methods on 3 domains: the time domain, frequency domain, and time frequency domain. And on time domain, we have the first 10 features in the red section of table, like means variance, standard deviation, and some feature using entropy like permutation entropy, SVD entropy. And on frequency domain, we have spatial entropy. And on the time frequency domain, we have 8-channel image composed by using continuous Weyl transform, showing in this slide. The figure 13 shows how to create an 8-channel image using continuous Weyl transform on time frequency domain. We have 8-channel easy signals and then apply continuous Weyl transform. We get an 8-channel image. And about classification, neural networks are the most modern machine learning algorithms in countless different fields, and the most optimal for variance or use in our study is our MLP, LSTM, GRU, and CNN. And they are shown in the 14th figure, the architectural proposed models. And in this session, I will show our results. The table 1 shows light detection results using proposed models for across 5 subjects, with the highest accuracy is on subject 2. We achieve is 98, around 98%, and the lowest accuracy we achieve is around 90.1%. 91%, around 91%. And the figure 15 shows accuracy and loss results on subject to using CNN models and 8-channel images. And we also experiment with subject independent and subject dependent strategy across 5 subjects. And the figure 16 showing classification results after using the proposed models. And as you can see, the highest accuracy is both subject independent and subject dependent strategies when use CNN and 8-channel images. And now I summarize my presentation. Our study, the study goal is propose a BSI system for light detection using an 8-channel custom design easy headset. And our proposed method, we conducted experiments from 5 subjects, and easy signals were pre-processed and extract to 11 different features and deploy 4 variants of neural networks for classification with the subject dependent and subject independent. And we get the results is the highest achieved accuracy is around 96% using CNN and 8-channel images features. So I will also show our future work, propose a real-time BSI system for light detection, optimize the current models, and apply other machine learning techniques for the proposed BSI system. And here's some reference that I use in our study. So thank you for your attention, and please give me some questions about our study.
Any question? Any question from the audience? Yeah, any question from the audience and online audience? You can ask on the mic.
So please give me some question from the online.
All right, then it's okay. Yeah. So basically, so one of your application is about detecting light detector. So compared with the polygraphs that already have been outside. So did you compare them with yours?
To be honest, because our device are custom, so if I want to add other data set and compares, it's really hard to compare with our device and the commercial device. I just get the data and is some experiments and compare it's quite the same. Quite same.
Okay. Okay, thank you. So the next speaker is Habibur Rahman. What is MD? Mr. Okay, you are the second person. Okay, so but the long distance real-time rolling shutter optical camera communication using IHCI modulation technique by Muhammad Abba Shakir Tezan.
Thank you, Chair, for your kind introduction. Good afternoon, everyone. My name is Mohammad Shizan. I am from Hokkien National University. Today, I will present our research work on long-distance real-time rolling shutter optical camera communication using MFSK modulation technique. So in the outline, first we'll give some idea about our research and our proposed system and the experimental setup, results of our experiment, and our summary and future work. So optical camera communication is actually based on the smartphone camera, which is based on a CMOS image sensor. And visible light communication, both are combined in optical camera communication. In optical camera communication, the user focuses his camera towards the light, and the light signals are modulated to represent binary data. So in this way, we can transfer information, and which can be decoded in the user's phone, and the information can be get back. So in which case we can use OCC, that tracking people inside the building, as we know that outdoor tracking, there's very good applications available now. GPS is very efficient, but inside a building, if we consider indoor localization, which is not, which is still being researched, and not a good solution is being found. So optical camera communication can be a way to find tracking people, also healthcare monitoring in a security system, localization-based system, broadcasting and vehicle communication, and an intelligent transportation system also. And some of the advantages, as we have seen before, one speaker or keynote speaker has showed that RF is being suppressed, as we know that the radio frequency is being is constrained and is not infinitely available. So we can shift into visible light communication which can be a good alternative because it has high bandwidth, high capacity. Also, no extra infrastructure is needed for this one. Also, it's secure and cost effective. The light signal can be sent and can be received by the photodiode or some image sensors. So the basic advantages are it's not harmful to human health. Also, it's no interference here, and the license and the bandwidth is not licensed. We can use. So in the receiver section, we can use any kind of photodiodes, and in the transmitter, we can use normal bulb like LED bulbs. So the challenges are that the synchronization between the transmitter and the receiver is a problem. Also the data rate efficiency, because the camera communication is a little bit complex. So that's why the data rate cannot achieve higher, we cannot achieve high data rate. Also flicker-free modulation and the higher order modulations and image sensor architecture. So in our system, we proposed like this, that we have the first computer and some data which is transferred into the MCU. And then this MCU is connected to a LED driver circuit, which transfers the LED driver circuit's data, and then it's transferred to the light signal.
Sorry, I think you have not done this.
Full screen.
Yes.
You have to cancel previous one and then.
Yeah, that's what I'm doing.
Okay. No, this one. This one is not mine. This one is not.
Okay.
Yeah.
This one,
Yes.
right?
Yes. Okay.
Then here.
Next.
Next. Okay.
Okay, so as I was talking about that, the data is modulated using LED driver circuit, and one LED light is finally transmitting the signal. So in the receiver side, we use mobile phone as that means the image sensor, and we capture the strips which are being white strip and black strip, and we apply some image processing, and then we get the original data. So in the transmitter parameter, we use one atmega 328P, one LED light, which is 15 centimeter long. And we use MOSFET and also some splitter frequency to divide the data. Because if we use two consecutive data, sometimes we cannot read the data. In between, if there are frames which are lost. So that's why we use some splitter frequency to divide each of the other symbols. And in the receiver parameter, we use a smartphone, Samsung S8, and it has a 20 FPS we have used. And also the camera resolution we have used 600 by 800 pixel. And as you can see here, this figure shows that this black strip and white strip is representing this signal. As you can see, the C0101, this binary signal is represented here. And this white strip is representing one positive bit, that means 1 bit, and this black strip is presenting a 0 bit. So after receiving this signal, we applied image processing for which that we use some OpenCV algorithm. And also we designed a Android application for showing the user of the data, receiving data. So in the test bed, we have this view. This is actually 6 meter distance here. And this is the received data. As you can see, this is the sequence of data which is transmitted by the LED. And as you can see that this is the strips that representing 0 and 1 binary signals. So this is the decoding rate analysis that we are achieved more than 6 meters in the vertical distance, horizontal distance, and the error rate increases as we increase the distance, because as we go further from the receiver, the transmitter, then the strips become so narrow that we cannot detect. That's why as we increase the data, increase the distance, the decoding rate decreases. And in the bit error rate analysis, we have compared 2, 4, and 8 FFSK analysis. As you can see that the 8 FFSK has a better result because it transmits more data than 2 or 4 FFSK. So in the proposed system, we have the long distance optical camera communication for LED luminaries and image sensor, and a smartphone based embedded systems we have developed. For this one, we don't need any additional devices. We can use the existing LEDs. Also, it's a low installation cost. This system can achieve 100% decoding accuracy in the 6 meter or 5 meter distance. And this system can be applied in localization, tracking, vehicular system, and etc. In future, we want to implement this system for indoor positioning and also extend the communication distance with the data rate. Yeah, if you have any questions. If you have any questions, you can ask.
So any question from the online participants? I think there are two. Maybe, or they are talking about the chat, about the video, PowerPoint. Too many PowerPoint open, right?
Yeah.
Is it yours?
Oh, it's okay.
Is it yours?
This one is mine, yeah.
Okay, so I'm not going to remove it. This is not yours, right? No time. So, okay, so if you have any question, please send them an email personally, or you can meet them offline. Thank you. Thanks for attending the session. Okay. Oh, no. Okay. Yeah.
All right. Okay. So now we have session 2 here, cognitive learning analysis. So we can see Professor Arvind is here. Professor, can you on your mic? Yes, perfect.
Yes.
So now I think you can take care for your session, and you have, I think, 7 papers in your session, and you can contact with the authors one by one. They can share their PPT slides using Zoom, so we can. Is it okay? So
Yes.
yeah, so we can.
We have already shared video recordings also.
Pardon?
Video recordings of some of the presenters.
Yes, I received some of the presenters video recording, but if they are here, so it's better to they can present live. It would be much better, right? So if there are some problem, then we can use the video file, but it's better to they can present. Yes.
So I invite Varsha Lokre then.
Okay, sir. Just a minute, I will share my screen.
Yes.
Whether screen is visible?
Not yet.
Not yet.
How can I stop our screen, right? I think we are sharing our screen.
Netflix off.
Sejan, can you come here? think we are sharing our screen. How to stop? Okay, we should stop our screen sharing.
Okay. Maybe that we discuss.
Yes. One second. Is it connected? No? Oh, this one. Yeah, we can have to stop this screen share.
Oh, no, no.
Stop share option may be there.
Can you share now? Can you check it?
No, sir.
Just hold.
I think from your end, there must be stop sharing option. You need to click on that.
Please screenshot. I think we can do it now.
Now they can. Now they can.
Hello. Now you can
Yes,
share
sir.
your screen. Yeah, now you can share.
Okay, just a minute, sir. Is it visible?
No, not yet.
Open the power.
Can you open your PowerPoint
And then see.
and then share? And then share, then it will be okay.
Okay, I have already opened that. Just a minute.
How can we make it?
There is error like your browser is preventing access to share screen.
Now you can try.
Is it visible?
No, not yet.
No. From your end, sir, sharing is not stopped yet. So what to do?
Okay, so could you send me, okay, let me share your speaker. So, okay, we are trying to open your slide, so no problem.
Okay, sir, please.
On PPT or video? Video.
Video.
Okay, so we are opening your video, so it's okay. After that, we can discuss. Okay. Can you call Madhu again? No, okay. No. फाइल नहीं शेयर हो रही ना, ये फोल्डर शेयर हो रहा है। चेक करो ठीक से। वीडियो फाइल ओपन करके तब शेयर करना है ना, पहले ओपन करना।
here is related to problem solving, intellectual activities, etc. So here in this research, brain signals have been captured during performance of arithmetic calculations, also by reading technical articles, as students are listening to technical podcasts, by their brain aspects. But when students are learning just relaxing with open and closed eyes, what changes will be there when brain frontal lobe that in later. This is the proposed model in which that capture input signals have been considered as an input and pre-processing of that signals. It's while recording signals of noise may be there, so within that particular noise from input, we require pre-processing. After that pre-processed signals, having same to machine learning model. So here, total 4 to 5 machine learning classifiers have been considered. And computer particular proposed model is converting concentration data by over billion and a billion kilo. So here I have considered there are different frequency bands like alpha, beta, gamma, theta, beta. Okay, these bands have been considered as a features for concentration level measurement. Along with that, one more feature has been recorded that is the time step, like at morning session or at afternoon session, where we have captured that particular brain signal from Schubert's brain. So that time also recorded. I have for feature selection. And from that it is observed that the time doesn't matter. On this particular graph, we are able to see importance of that time feature is less than 3. So just timestamp feature parameter and view for analysis. Then we are able to see experimental work, which I have undertaken, in which total 7,243 data paintings are considered for analysis purposes. Features beta, theta, gamma, and delta from 0 to 3. Machine learning algorithms or classifiers considered over here announced maybe based AML, SVM, and BCMD. Out of 7,243 data points, 70% data used for training purpose and 30% data used for testing purpose. So total sample test data considered here is concentration level data units 589, medium high concentration level data units 574, medium low 852, and low 158. And for analysis purpose, whatever data collected, some concentration level scoring has been completed. That is between 0.8 to 1. It considered as a class 3 and concentration level assigned for that high concentration level. For 0.8 to 1, high concentration level. Similarly, they can have to also for 0 to 0.2, class 0 and concentration level low. These four permissible variables has been considered over here. So expected concentration level generally based upon which task goods are being. The expected concentration level is shown as shown over here. Like when performing mathematical calculation, generally high concentration level is required. Generally, a particular student can able to solve that. While suppose the student is relaxed, not doing any intellectual activity, at that time, only concentration is required over there. So that comes under low concentration. Here, accuracy of each and every machine learning classifier is compared and analyzed. So, total 5 machine learning classifiers considered here at almost many ways, AML, or Brazilian and decision. So, from this, you can able to see AML machine learning classifier gives highest accuracy as compared to other classifiers. So the reason behind here is what? That alien classifier, alien machine learning classifier, generally works on brain, how exactly one brain works. So similar working is there for alien machine learning. That is the reason why we get more accuracy for this EEG-based concentration level measurement system. Coming then for DB-based lowest accuracy you know, have to observe over here. So reason behind that, in DB-based machine learning classifier, generally doesn't consider the relation between features or parameters. But here in this particular application, that relation between features is very much important. That's why here we have to see for negative lowest accuracy is key. And also analyze this on the basis of other parameters like confusion analysis there, precision, recall, and enhanced score. Then we can able to observe for prediction of particular concentration level. Say suppose for class 0, low concentration level. Here we can able to see decision tree gives better result as compared to other classifiers. Similarly, for class 1, we can able to observe for class 1 very low concentration level and it shows more accuracy. Okay? So, likewise, precision recall and data score is also given over here. And we can conclude that concentration level prediction system is proposed by performing various types of cognitive tasks. And we propose every modeling system aims to predict concentration level of students during the performance of multiple tasks. This work can be extended with the deep learning algorithm to achieve more accuracy. Refer is references. And
Is there any question? So, Lopre madam.
Yes, sir.
Are you going to use any other method other than EEG in future work, like galvanic skin response?
Actually, I have planned to use EEG device for capturing brain signals. For that, many devices are available, like emotive, and various companies provided that EEG devices. So I'm going to apply that particular emotive device, which is around 24 channels, so that it can able to provide more accuracy while capturing brain signals.
Okay. Is there any other questions from audience? Can I call second presenter Indranath Chatterjee?
Let me just. Am I audible?
Yeah.
Yeah, thank you. Just let me just. Hello. Hello.
You are audible.
Oh, okay.
You can
So can
start.
I start now?
Yes.
Okay. So very good afternoon, everyone. I'm Dr. Indranath Chatterjee. I'm currently working as a visiting professor in Tongmyong University in Busan, South Korea. So this work is based on a project by my students, and today I'm going to give you a presentation on that work. So the work is based on an NLP and LSTM based stock prediction and the recommender system for a COSDAC and COSP. So the other co-authors are my students, John Guan, Yong Jeng Kim, Min Sok Lee, and Professor Myogung Cho. So I'll give you a presentation in a very traditional way of telling some background. Then I'll talk about the related work, and then I'll talk about the motivation, that how we have chosen this topic. Then quickly I'll go through the objectives, and then I'll talk about the materials and methodology, and I will conclude with our results and conclusions. So basically, we all know that stock market prediction is one of the complex analysis of all time, even today. And different experts, analysts, as well as computer scientists and statisticians and different market analysts are all working for the development of a stable and robust platform for the prediction of a future stock value. So, and it's still under very huge research. The primary challenge is the nature of the movement of daily price. That means it increases rapidly, sometimes it falls rapidly. So there is no fixed sequence or no fixed idea that how it goes. So, and it depends on various factors like economical factor, environmental factors, and sometimes some natural calamities came. So all these affects a lot. So before this study, we have gone through several rounds of literature reviews. So we have found that recently the machine learning applications are working very well on the stock market prediction analysis. And beside the machine learning algorithms or the traditional machine learning algorithms, artificial neural networks are also employed to build the recommender system for the stock market. In sense of artificial neural network, mostly the CNN and the RNN are mostly used. But in very recent days, so I found that LSTM is recently being used. A very few studies, although, but still LSTM is being used as a part of or as a tool of prediction system for the stock market. So alongside this prediction part, a few studies, not a couple studies, but a few different studies, which I found that some of them are using NLP also to suggest or recommend something on the basis of different tweeters on news. So our motivation was basically the stock market prediction, to build a stock market prediction and recommender system based on stock news, which has not been explored well together. We find very few studies on the Korean stock market prediction involving both COSDAQ and COSP data. Thus, we are very curious to explore the Korean stock market for developing a robust prediction for the future prices, along with understanding the complexity of the market trends. So, to the best of our knowledge, this study is the first of its kind to propose a machine learning based prediction model and an NLP based recommender system coupled together for both the COSDAQ and COSP data. So we have taken three major objectives of the study. First objective is the primary objective, that's to predict the future value of the stock as desired by the user. Second, to recommend the user to hold, buy or sell a particular stock which is being desired by the user. And the third, to suggest the user by recommending the probable month and time of the month to buy or sell to gain the maximum profit. So in this study, we have used three different types of data. First, obviously the stock market data. Second, the news data, and third one is the Twitter data. So in case of stock market data, we have downloaded the last 10 years data of 2,500 companies, including KOSPI and KOSDAQ from the Yahoo Finance, including the present day. And for the news data, we have used the Google News and Yonhap News both for analyze the news data. And for the web scraping, we have used a lot of different English stock market news websites and blogs related to the Korean stock market. And for the Twitter data, we have fetched the tweets from different companies using the Python Twitter API. So this is the schematic diagram of a proposed approach, basically. So in this proposed approach is basically divided into three different steps. So first step deals with the past data, second stage deals with the present data, and the final stage deals with the future data. So I'll quickly go through the one of them. So as we can see that the stage one, I just told you, it's entirely deals with the past data. That means we have taken from yesterday to the last 10 years, we have analyzed all the data. We have explored the 10 years data to find the highest and the lowest closing value for each month of the year and subsequently for each year in the last 10 years. We have measured the frequency of high prices and also low prices for each of the month in each year and try to find the correlation between the month of the year and the stock prices. We perform the same analysis and same correlation for also days and months and correlate with the stock prices. After obtaining the frequency, we have ranked accordingly and choose the most occurring months and week of the month in all the year. This analysis actually helps us to understand the daily, monthly and yearly trend of the hike and fall of the closing price. Now, after getting all this, doing all the analysis and getting all this understanding, we have taken a 20 days of window. So, and this window has plus 10 days and minus 10 days of particular day, which has the highest peak in terms of hike or fall. So, and we fetch the news from Google News and Yonhap News for that 20 days window and apply the NLP analyzer and to understand that is there any clue for the sudden hike or sudden fall, which actually helps us for the future prediction. Now comes to the second stage. The second stage of the model deals with the present data, including the same day as the user is performing. So in this stage, we have used the Google News, Yonhap News, and Twitter data to comprehend the present condition of the Korean stock market and also to find the latest data of the entire Korean stock market and also the desired company by the user. So the contents were fetched and converted into the standard form for the processing of the NLP. I'm not going into deeper into the NLP thing. So with the application of sentiment analysis in NLP, different scores were assigned to each news by scoring whether the article was a positive, neutral, or negative. So summing up the respective scores, we yielded the sentiment for the overall situation of the Korean stock market. Same thing we have done for the each of the company's data. First, we have understand what is the current status and situation of the entire Korean stock market, and then we have considered the same thing for the individual companies. So this, I'm sorry. So the stage 3 of the algorithm or the proposed methodology deals with the application of the LSTM. So here we have not used directly the LSTM, we have tuned the LSTM in some way. So we have used a sequential model of the LSTM algorithm using a keras, and we have considered the number of epochs to be 200 and the number of neurons in the units as 64. So during the compilation of the model, we have used the ADAM as an optimization parameters and mean square error as a loss function. The whole data set was cross-validated using 60% as a training set, 20% K for the validation, and the less than 20% for the test set. Along with this 60, 20, and 20% data, we have also take some arbitrary data sets for some future values for say next 1 month or next 2 months, just the dates without any values, some arbitrary dates. So that's the extended test set. So we preferred to measure the R-square value as a matrix for the efficiency of the proposed approach, and to find the efficacy of our proposed approach and to compare the model, we have also experimented using linear regression and the Facebook profit model. So out of the 2,500 companies, we have randomly selected 83 companies and tested on the result for this work. So we get very promising results in terms of R-square error for the three major companies of Korea. So this is the work culture. Like if we find something like LG Chongja, means LG Electronics, if you want to buy for it, we get the recommendation, we get the today's price, and we'll get the suggestion for the future data. I'll show you the result. So for example, if you want to find the result for the Samsung Electronics, so first it will show the today's price and the last day's price and how much increase it was there. Then it will recommend that for the user that it is recommended to buy this stock only during the month of January and December, and it is also suggested to buy this stock during the 3rd week to get more profit. This understanding our model used to get from the understanding and learning the last 10 years trend. And also it is suggesting that okay, the Samsung situation is currently good and the entire Korean stock market is currently good, and it is also giving a trend for the last 1 month. Along with that, this 3rd stage result shows the very promising result for the LSTM, and this yellow line is the predicted data, and this blue and this green are the validation, and this blue is the test data. And we find very promising results on the validation test both. So the key challenge of the nature of the ever-changing movement of the stock price was the daily price, that is rise and fall of this daily price. So here we proposed a 3-stage model coupling the recommender system and the prediction system, both for COSDAQ and COSPI, for the first time in this field. So this study is based on the usage of NLP and the usage of LSTM to analyze, comprehend the past and present market scenarios and to predict the future value of the stock. The paper successfully presents the current condition of the stock and overall Korean stock exchange. It also recommends the potential months and week for the investment to achieve more profit, and this is like the our benefit, our extra contribution. And overall, it predicts the future value of the stock with high accuracy in terms of R-squared value. And we find that LSTM gives the best prediction while comparing with the other state-of-the-art techniques. So this is my project under the research grant from the Ministry of Science, ICT and Future Planning, Government of Korea. And this project was done by research students and supervised by the IITP. So these are the references that I have used in these presentations. Thank you everyone for listening. And if you have any query, I'll be happy to help.
Thank you, Professor. You have presented very interesting and challenging problem from the point of view of big data handling.
Yeah.
And I have some few queries. Is there any specific reason to select LSTM?
Actually, among the because CNN and RNN are built for different functionalities, and in terms of RNN, so LSTM is these days LSTM is gaining popularity just due to the forget cell, because in that cell there are different gates in the LSTM, and the forget gate helps to understand, remembers, and the forget the last learned weights.
I have one suggestion rather than question.
Yeah, surely.
See, the type of data that you are handling is the time series data.
Yes, time series data.
Particularly stock data, not the news and that kind of data. And in time series data, detecting events like falling of particular stock price or rising, these matters most. And if you use this event detection technique in time series data for recommendation purpose, that may be a very good work.
Okay, I'll must show. I'll must check it out, because
Yes.
I just need some few days to wrap up this project. So I'll must consider your suggestion. Thank you so much.
Thank you. Thank you.
My pleasure.
Now I invite a third participant, third presenter, John Reem.
Okay, his video file. So I think Professor, he is not here. So we can see his video file till we can move another speaker.
Yes.
We can move to the paper ID 54.
Yeah. 54.
54 is there video?
Manjushri, no, video is not there. But yeah, says here.
She didn't send the video, or right? Paper ID 54.
See, I think paper ID may be different one.
Is it different?
Not 54.
Paper ID is 54. That's
Right.
send it as 56 in the video.
All right. So you are going to present, right now?
Sir, I will try my screen. If it is, I will present.
Say again, we couldn't connect you.
I will share my screen. PPTs
Yeah, you
are
can say.
available. I will present.
Yes, you can share now. It's already started.
First, open your PPT slides and then share it. That would be great. I think he is there. Paper ID 55. Here. No, Sonu, आ जाओ.
Hello.
Yeah, it's loading. Yes, we can see your screen now. Can you open your slide?
Sir, my slides are already.
No, slides not opening. The page are open here. So first, I think you should open your slides and then share the screen of your PPT slides. The folder is sharing where your slides was saved. So I think cancel again. Go back.
Yeah, just double click, try to open. Slow and network slow, bandwidth slow. ये तो नीचे है, ये भी यहाँ पे बैठी है। सारा तो बहुत से ये है, इसका वीडियो है, इसके अलावा भी वीडियो बनाए इसके ज्ञान की वीडियो चला तो अगर एक वीडियो है जो परेशान हो रही है वीडियो से चलो ना।
Available, sir?
It is loading. It's not yet.
कौन सा ये इनका है ना, है वीडियो 45 का है ना वीडियो।
हाँ चला दे।
बोल दो 56 का वीडियो।
So we got the video. So we are going to open the video 40. नहीं इनका जो भी कर रही है
56 का इनका नहीं है ना वीडियो।
56
Video नहीं,
I think 56 है।
56.
Yes.
56 का है।
Okay.
Present. ऐसे करो। तुम उधर बैठो। Hello.
Yeah.
Yeah. Paper number 56 going to present, right?
Yes.
So, Professor Manjushri, can you close your sharing? Can you stop your sharing?
Yes.
So,
Yes, sir.
yeah, thank you. Now, yeah, Gabit, can you share your screen and present? Paper number 56. Can you share your screen and present? Yeah, thank you.
My name is Rabi Tolendiv. I'm a graduate student at Dongseo University. I'm going to present my paper titled Adaptive Margin-Based Liveness Detection for Face Recognition. Here is the outline of my presentation: background information, motivation, proposed method, results, summary, and references. As we all know, due to convenience and accurate and security reason, face recognition utilizes more than other biometrics such as fingerprint, palm, iris in person authentication systems. However, as the technology develops, it encounters the problem of spoof attacks, which is carried out using a fake face image by a non-authorized person. Here is the examples of spoofing attacks, like this prints attacks, get paper, and the replay attack. replaying video or photo on smartphone, and the 3D mask attacks, making 3D shaped face of the person, and spoofing with this the system trying to get authenticated. In order to prevent this kind of attacks, we apply liveness detection on our biometric person authentication systems. Liveness detection aims to distinguish real faces and the fake spoofed images, and it is applied to person authenticating systems to prevent print attacks, replay attacks, and the 3D face mask attacks. Traditional face liveness detection methods use images which covers only face area, shown in picture A. However, the area around these face images as images B. Also, they include some useful features to distinguish real and fake face images. For example, in replay attack image includes phone edges and hand fingers. So when we train our liveness detection model with these images, and also test with these images, it might improve. It will improve this classification accuracy. Here is a block diagram of the proposed face liveness detection system. First, face captures. We capture face images from the web camera and pre-process it, such as intensity normalization, and detect and capture face images and capture 2 times larger face area, extract face features, and comparing the images in the database, are the images, real and the face images in the database, we make decision to whether this is real or fake images. If it's fake, we reject to authentify this person. If it's real, we proceed the face recognition process. Here is the network architecture of this proposed method. This is 60 filters, 32 by 32 shape, size 16 per filters, and followed by max pooling, and the next 16 also filters, 16 by 16, and 32 filters, 16 by 16, followed by max pooling, and we concatenate fully connected layer. Finally, the softmax activation function. We distinguish, we make decision, threshold fake and real face images. This network has 147,922 parameters, so it considers a lightweight model. It can be also run in resource constrained devices such as Raspberry Pi. So this is our method shown illustrated in these images. This is a raw image captured by web camera. The traditional methods use only this face area. So we detected, captured by this face detection model, such like a ResNet. And then in this, we are capture 2 times larger this ROI, region of interest. So images to process, and that's why our method calls margin based. There is a margin. In this slide, illustrated some of the collected our databases, fake and face images for training and testing. First row shows the real face images, and the second row is the fake face images. So as we can see here, there is these fake images include this phone edges and hand fingers. So we evaluated our model method with F score, calculating this, calculated by this equation. First we calculated confusion matrix. There is this column is a true level. We tested our model with 200 images of 20 subjects. Each person, we used 10 images of each person. And calculated this precision. This is true positive, this is false positive, true negative, and false negative. And calculated this precision and recall value, and after that calculated F1 score. So here our F1 score is 0.996, which is quite high, considers quite high. Here in this slide, results. We tested our model with printed paper. So our model recognizes as this fake. Here, test with photo captured shown with smartphone, also recognized as fake. And these pictures, it's me. I'm sitting in front of web camera, so it's real image, distinguishes as real, with the accuracy 0.97, like 97%. So in this work, we presented our liveness margin-based liveness detection model, which is distinguishes real and the face images that can be applied in face recognition systems. So experiments on real and fake images show that the proposed methods detects real and fake images in the real time with the high accuracy. So this is the first paper that uses this margin-based liveness detection for distinguishing real and fake images. So in our future work, we are going to increase this data set, our data set, and try to different persons try to gather more data sets in order to improve our performance. Here is the references. Thank you for your attention. Any questions and comments are welcome.
Thank you, Gabby. In your approach, is it correct that you are differentiating between image that is captured by web camera and static camera?
Web camera and yeah, image from treated image and the image in screen device.
And you are interpreting that the image that is captured through web camera is the live image.
Yeah, yeah.
Thanks. Thank you. Nice work.
Thank you for your question.
Any other question from audience? Now, next speaker is Jyoti Borade. Jyoti, can you share your screen?
Do not put it here. Put it somewhere else. Okay, what's my time? No, they say you must present.
Jyoti, can you share your screen?
Jyoti, are you there? No. No, I think she is not here. I think we can go next.
But
speaker.
Swanand.
Okay.
Swanand?
Yes, sir.
You can start your presentation.
Yes, sir.
Yeah.
Good afternoon, everyone. Myself, Swanand Navandar, PhD research scholar from Dr. Babasaheb Ambedkar Technological University, Donare. A two-system perspective for computational thinking. So, outline. So, we are going to see the what is computational thinking, Kahneman's two-system model of thinking, motivating example, characteristics of two-system model, computational thinking activity mappings and application based on two systems and conclusion and future works. What is computational thinking? So in computational thinking, it is a complex thought process involved. So for this, set of skills is required, like problem solving using computers and designing and evaluating a complex system and understanding human behaviors. So computational thinking is basically psychological theories are required, and computational thinking based on that we can find the human behaviors, understanding the human behaviors. So computational thinking is different from computation and programming. So why we need to modelize this analyze computational thinking, because basically we are learning this computational thinking from KG to PG, and this is very complex thought process involving the problem solving, decision making, and understanding human behaviors. But existing framework is not uh, using this psychological dimension. They are only using the design and guidelines. Yes. So Kahneman's two system model of thinking, in which there are two systems. System one is called as fast thinking, and system two as slow thinking. So system one is unconscious, automatic, and everyday decisions can be taken with the help of this system one. And because it is very fast, so there may be error, chances of error in this system. In case of slow system, uh, it is conscious. For this system we have to take an efforts, and complex decision are taken with the help of this system too, and it is reliable one. So example for this, consider if we have the question of 2 plus 2, then there is the answer as 4. Yes. So you can easily get the correct answer with the help of this. Uh, and in case of system 2, if you consider this 17 multiplied by 24, then you have to uh, uh, take efforts and deliberate calculation for doing this 17 multiplied by 24. But in case of 2 plus 2, you can directly get answer that 4. Yes. So system 1 we are using for solving such a problem, and for solving 17 multiplied by 24 we are using system 2, that is slow thinking. Consider the example of error prone. So if you here the bat and ball cost is given at $1.10, and bat cost is $1 more than the ball cost. Yes. So here we have to find what is the ball cost. Yes. If we are using system 1, then what happening? If we are using system 1, then answer is given by most of the student that $0.10, that is 10 cent, is the ball cost. And if you consider the 10 cent as a ball cost, then what is total bat and ball cost is $1.10. Yes. So answer is wrong. But if you think slowly, then you can get the cost of ball is dollar cost of ball is $0.05 dollar. Yes. And then total cost of bat and ball is $1.10. Yes. So here whenever we goes fastly with fast system, then it will be error. Yes. Consider this example of example 3, in which we have conducted the exam paper, in which we have asked the student program 1 and program 2 we have given, and we have asked the student that which of the programs shown in the table swap the values of x and y. Yes. So swapping logic we have used and asked the student, and there are 4 option multiple choice we have given, that program 1, program 2, and none of the program 1 and program 2, and fourth is for both program 1 and program 2. In this case, out of 83 student, 70% student given the answer that program 1 is solving the answer, but the correct answer is both program 1 and program 2. Yes, because if you see here, so here the addition subtraction logic is there, and deliberately we have to use addition, concentrate and subtract this value of y, and then you can result whatever the result obtained from program 2 also swap the value of x and y. Yes, so this is what the slow thinking, if you take efforts, so you can get the proper answer. So characteristics of dual system thinking is that both system 1 and system 2 work concurrently, because system 1 provides whatever the replies, and system 2 gives replies to system 1. Yes, the two system model represent a division of labor works. In this we are dividing the labor work, that is yeah, like system 1 and system 2. Yes, so in this whatever we are work is there, we can divide between system 1 and system 2, and bias and heuristic guide the system responses. Yes, so consider the computational thinking activity in which system 1 and system 2 in this computational thinking activity, we have a decision deciding, we are mapping this computational thinking activity between system 1 and system 2. Consider first example of deciding upon primitive data types for variable. These primitive data types we can easily find out. Yes, without any effort we can get primitive data types. So it is of system 1 type. Separating the user defined identifier from language defined one. These also system 1 problem, identifying the input and output of given function. Yes, if you want to find what is input and what is output, so it can be easily find out with the help of system 1, and separating comments from the code segment. These are the different cognitive activities, computational thinking activity we are separate out in system 1 and system 2. Second, that in system 2, decomposing a large program into smaller program, and which is also reusable. Yes, for this we have to take an effort, and we have to find the large problem we have to solve into reusable program. Yes, second, the deciding upon the data structure, that is which data structure we have to use for solving the problem, that is stack, queue, free, tree, graphs. Yes, and third one, that performing tree or graph traversal based on pre-order, post-order, breadth first or depth first. Yes, so like this we have to use yes, said system 1 example is that next is that if you want to perform this push pop operation on the queue or stack, so we can get the whatever the pushing element, what is pop element, what is front and what is rear of. Yes, so this kind of operation action can be easily performed with the help of system 1. Yes, and you can easily find out this operation. So it is of system 1 type. Finding the root of the leaf nodes in the binary tree. Yes, this is can be easily get root with the help of binary tree. And categorizing machine learning problem, that is based on the scatter plot. What is it is linear regression or classification or logical regression or clustering. So this can be easily identified with the help of system 1. Last, and here the decision upon when to use data driven or arithmetic logic is of type what? System 2. Yes. So two system model and computational thinking, there are some example of application separating concerns such as business logic from communication, coordinating and other such concern. Second one, it is of system 2, because for solving this problem we have to deliberate, take an efforts, and time also consume. Yes, so answering the question like how difficult to solve given problem through computers and perform complex analysis, complexity analysis. For this we have to take effort, solve and problem, recognizing the situation where the approximate solution may be sufficient. And last one is that code inspection for compliance and violation of programming guidelines, such as name of class in object oriented shall be noun and name of the method shall be verb. So these for we have to identify with which is class and which is method. So for this we have to take efforts and solve this with the help of our psychological behaviors. Yes. So application of DL system model in computer science to decompose the information processing system, that is between what is system 1 and system 2, to analyze the role of bias in software engineering, and also to analyze the cognitive activities. Finally, conclusion and future was KMN's two system model is rich as cognitive analysis framework, which can be used to study human perspective of computational thinking. So paper also illustrate the what are the different applicability of two system model mapping in computational thinking activity.
You can use.
And it will be interesting to explore the role of this bias and heuristic in context of computational thinking. Thank you very much.
अभी 8 साल हो गए हो.
Thank you, Swanand.
Yes, sir.
So, how you are going to measure the effort that is taken by user?
Sir, we have we are using the system 1 and system 2 means timing we are using, that whether it is using based on time slot, we can find out whether he is if time is less, then it is of system 1 he is using, and if he are taking efforts, then time required for solving that require more times, so it is slow system. So slow system taking the more effort than the fast thinking.
Is there any question from other audience?
Sir, can I ask the question? I'm Dr.
Yes, yes, sure, sure.
Yeah, in this work, if you are taking a variable name, a different name, instead of if in the example you have shown both cases x and y as the variables you have taken. If some students, if you're submitting, you're asking the students to submit some work kind of thing, and the system has to analyze. The student may take the variable in different context, different name kind of thing. So is it your system is going to handle that one?
In this we are using this for whatever the time slot student is using for solving the problem.
Yes, you are taking the time slot, and for example, to use your system, the computer need to analyze. So we have to instruct the student to use the variables name as this specifically. Otherwise, if the student is using the different names, context kind of thing, still your system is going to handle the problem.
We are providing the question directly to the student, and then analysis the whatever the they giving the chances of questions. Means multiple choice question we are giving to the student, and we are analyzing the what is the output of that one. Means which choice they are selecting.
Okay. So yeah, thank you, sir. Yeah, I got it. Yeah. Thank you very much. Good work.
Any other question?
I think we don't have any other further question. So for the paper ID 72 and 54, we have received the video. So can we play? We are going to share and play. So Professor Arvind, can you let me know that which paper ID going to first? So we will share the screen.
Manjusri, this the sequence with which they are having. I think it is Manjusri and Jyoti, I think.
Sorry. Sorry, can you repeat, Professor?
1 minute.
Okay, I'm going to share with the
54 you can share first.
Okay.
Then
54.
72.
Okay. Is it audible?
Yes, sir.
Yes, I think audio is not there.
The example of analysis is compare contrast classification example categorizing transaction outcomes.
I'll take it.
Example of this graph evaluate the select, value, measure, validate, consider. The last one is a failure. Moving element all together to form a new pattern or structure or function. The example is here. Predict global population. These are the examples of the failure. actual wealth. The accumulated wealth is the basic knowledge that the student must understand while learning the software engineering. It is able to solve problem. It is able to something they have already learned and find out what exactly the solution.
Let me take one minute. Light is coming. This place. Let's one professor here. Mic बंद नहीं है क्या? Mic.
Hypothesis. So our null hypothesis is that cognitive skill and knowledge dimension are independent. And our H1 is cognitive skill and knowledge dimension are dependent. So to calculate the chi-square, the formula is that x square is equal to summation of observed frequency minus expected frequency whole bracket square divided by expected frequency. Here contingency table is created for the observed frequency and for expected frequency. In that contingency table, the columns are cognitive processes and knowledge dimensions are in the row. So whatever the question atoms, number of the question atom which falls under the conceptual and analysis are 21. Number of the question atoms which falls under conceptual and apply are 11. Number of the question atoms which falls under conceptual and create are 1. Like this way, for each cell, the values are calculated. And to calculate the expected frequency, there is a formula, that is row total multiplied by column total divided by the grand total. So for each cell, that value is calculated. Now we have both observed frequency and expected frequency. So we can able to calculate the chi-square test. So already we had seen this formula. We have both observed as well as expected. So we can able to calculate the chi-square test. So here the probability is 0.95 and whatever the chi-square test value we had calculated, that is 336.77 and the critical value is 18.30. This p-value is less than 0.05, that is our value is 0.000, which is less than 0.05. If our p-value is less than 0.05, in that scenario we have to reject our null hypothesis and we have to accept our our hypothesis. Our hypothesis is that cognitive skill and knowledge dimension are dependent, and this can be proved with the help of this contingency table. If our observed frequency values are greater than the expected frequency value, then there is a relationship, there is a correlationship between the cognitive process and knowledge dimension. So first we will see the conceptual. In a conceptual, the observed frequency for analysis 20 is 21, in expected it is 16. So our observed is greater. So in this case, there is a relationship between the conceptual and analysis. Now we will see the factual. In a factual, our observed observed frequency of remember is 99 and expected one is 33. So it is greater. That's why there is a relationship between the factual and remember. In a procedure, where the observed frequency of apply is 46 and expected is 22. That's why there is a relationship between the procedure and apply. There is also a relationship between the procedure and create. There is also a relationship between the procedure and evaluate. So, so with the help of this contingency table, we can answer our all research question. Conclusion and future work. It is observed that there is a statistical significance dependency is present between the cognitive process and knowledge dimension. By comparing the expected frequency and observed frequency, it is observed that the significant level of dependencies are present between factual and remember. First one. Second one, conceptual and understanding and analysis. Third one, procedural and apply, create and evaluate. In future, we will consider more number of courses for generalizing purpose. Here we are considering only the single course software engineering to find out the dependency between the cognitive process and knowledge dimension. Thank
Can you take no questions?
Yes, sir. Thank you, sir.
So we have missed your earlier recording. You just briefly explain what is your work. What you did in the.
We have identified. Shall I start?
Yes.
Actually, we have collected 794 question items from the software engineering question papers of the 50 universities. And from that question paper, we have identified the question which falls under the cognitive process and which some question falls under the knowledge dimension. So we prepare a sample data set here in our PPT in which a question falls under the cognitive process as well as the knowledge dimension. Okay, so under the knowledge dimension, we have the three categories: factual knowledge, conceptual knowledge, and procedural knowledge. So the question may falls under the create factual, evaluate factual, analysis factual, apply factual, understand factual, remember factual. So in this way, the questions of question may be categorized with the knowledge dimension and cognitive science. So when we do this one, these are all categorical types of data. So for that purpose, we are using the here chi-square test to find out the relationship between the cognitive process subtypes and the knowledge dimension subtypes. So when we using the chi-square test, we got the results that our p-value, which is less than our significant level, that is our significant level is 0.05%, and we get the p-value 0.001, which is quite less than our significant level. So we reject our null hypothesis and we accept our alternative hypothesis that is there is a dependency between this cognitive process and knowledge dimension.
How are you going to extend your work?
Sir, here we had used only one subject, software engineering. In future, if we consider number of more subject, then we can make it generalized that there is really there is a dependency between them. There is an association between the cognitive process and knowledge dimension.
Is there any other questions from the audience? Thank you.
Thank you, sir.
So here I'm going to play for paper ID 72, Professor
Yes,
Jyoti.
Yes, yes.
Can you see that video?
Yeah.
Okay.
Good morning, everyone. I'm Jyoti Borade and my guide Lakshman Netak sir. So here we are going to present the automatic grading of essay. This is my review paper. This is the outline of my today's presentation. Why automatic grading of the essay? Which data engineering tasks are required for that purpose? Which methods are used for automatic grading of the essay? And which metrics are used to evaluate the model that is developed for the grading of the essay? Then comparative study for the using different approaches, conclusion and future work. As we know that examinations are important in evaluating students' knowledge and skill. Evaluation can be done by using multiple choice questions, fill the blanks, match the pair, answer in word or essay type question. The MCQ type question examinations have many limitations, such as it is difficult to judge the knowledge or critical thinking ability of student through MCQ based examination. Such type of examination fail to evaluate acquire knowledge or to increase the learning ability among the student. While in essay type exam, teacher can assess the learning ability through the student written response. Thus, they are making the essay type exam more effective mode of assessment. So essay type of evaluation is a kind of assessment where teacher have to evaluate the descriptive answers written by student. As we know that evaluating this descriptive answers is a challenging task because it is often laborious, requiring more time compared to multiple choice questions. And also this evaluation process is subject to lead to inaccuracies and considerable variation in grading depending on the different evaluators. Many researchers have developed this grading system using different approaches for many natural languages like Indonesian, Chinese, Arabic, Punjabi, and Japanese. Now we'll see the important data engineering task required for the automated grading of the essay. Before developing the model, we have to go through this data engineering task. The first one is the feature engineering. So as we know that in the machine learning model, we require the feature and feature extraction is important. So if we'll see the lexical feature, these features include the complete word, prefix, suffix, stem word, lemmatized word, capitalization, and punctuation. If we see the syntax and grammar related feature, these are the features like part of the speech. So here the uses of the noun, verb, preposition, conjunction, vocabulary, and spelling. If we see the semantic feature, these are based on the correctness of the sentence and meaning of the sentence. So include the feature like vocabulary per passage, percentage of difficult word, then proportion of the grammar error. So these are used to determine the semantic correctness and meaning of the sentence. So here we can see that features can be extracted by using various NLP tool like NLTK, that is a natural language toolkit used for the part of the speech tagging and stemming. Then we can see that Aspel used for the spell checking. So many softwares are available. Here I have listed only Aspel. WordNet is used to search the synonym for the given input, and scikit-learn is used for extracting unigram and bigram features. Deep neural network based approach here we don't require the feature engineering because it is based on the automatic feature extraction, and this is the beauty of the deep neural network. Then word embedding. As we know that this automatic grading of the essay, it is a classification or regression task. That means we are classifying it as the good essay or the bad essay, or we are assigning score. So it requires the many feature for accurately predicting the score of the given essay. And these techniques, this works on the numeric data. That means we have to give the feature in the numeric format. So that is why word embedding is the technique that is used to represent the each word of the text into the vector format. And for that, tools such as word2vec, then this glow vectors, these are used to produce these word embeddings. And these models are pre-trained models. They are constructed using the continuous bag of words and skip-gram model. So briefly, we'll see about the continuous bag of words and the skip-gram model. So here, if we'll see the continuous bag of words, here we can see that it is a two-layer model. Skip-gram, it is also the two-layer model, one hidden layer and one output layer. Here also the one hidden layer and the one output layer. The only difference here, if we'll see, in the continuous bag of words, it predicts the probability of the output of a single word for the given input context of the words. And this skip-gram, it is the reverse of the continuous bag of words. Here it predicts the probability of the context of output words for the given single input word. Then this measuring the text similarity. So as here we can see that this approach is also used to give the score to the student's answer. So here what is done, student's answer and the reference answer, they are compare. So they are compare by using this Euclidean distance, cosine similarity, jacket similarity, Dice coefficient, Levenshtein distance. So obviously for doing this comparison between the student's answer and the reference answer, so we have to convert it into the vector for vector representation by using the glow or the word2vec, and then we can find out the similarity between the student's answer and the reference answer. And depending on the similarity that we are getting by using any one of these measurement, we can give the score to the student's answer. So here we'll see the briefly about this Euclidean distance. So here we can see the Euclidean distance between the two vectors. So vector x and y, these are nothing but what? X is representing the vector representation of the student's answer and y is the vector representation of the reference answer. And then it is calculated by using this formula. Then if we'll see the cosine similarity, so it is defined as a dot product of the two vector divided by their norms. So AB, this is the vector representation of the student's answer and the reference answer respectively. Then jacket similarity, so it is calculated as the number of common words from both document divided by total number of words. Those are present in the student answer as well as the reference answer. So here if you see the Dice coefficient, so Dice distance, it is used to measure similarity between the two string. Okay, so here we can see that source string as the S and the target string as the T. So in order to convert this source string into the target string, so how many number of deletion, insertion, substitution required, that will be used. So here if we take the example, source string is cook and target string is book. So in order to convert this cook to book, so what we have to do, we have to substitute, we have to replace this C with B. So that is why one operation will be done. So hence LD distance will be 1 in this case. Then we'll see the metrics. They are used to evaluate the models that we have developed for the automated grading of the essays. The first metric is the quadratic weighted kappa. That is very popular matrix used by many researchers and is used to calculate the amount of similarity between the prediction and the actual evaluation. It generates the score 1 when the prediction and actual evaluation is same. So here we can see the formula of this quadratic weighted kappa. It is calculated in this way. Here we can see that O is O, W, E. These are the matrix of size n by n. All are having the similar size, and here n corresponding to the n number of essays. Here if we see the OIJ, this cell value, it gives us the count of the essay that obtains score I by the first evaluator and score J by the second evaluator. E matrix gives expected rating without considering any correlation between the two evaluations given by two different evaluators. And W is so here we can see that W, O and E, they are of the same size, and W is calculated by using this formula. Then this is another metric is used to evaluate the models that is developed for the automated grading of the essay. That is this recall oriented understudy for guessing evaluation. So here we are calculating precision, recall and the F score. So here precision is what? Number of common words present in the student's document and the reference document divided by the total words in the student's document. Recall, it is a number of common words present in the student's answer and the reference answer divided by the total words in the reference answer, or we can say the reference document. And F score is calculated as the 2 times precision into recall divided by precision plus recall. Then methods for automatic grading of the essay, machine learning. So machine learning, it is a basic technique for for the grading of the essay. So basic procedure is to start with the feature extraction, then construct the machine learning model by using any one of the basic machine learning techniques like regression, then random forest, then support vector machine, and then build this model that relate this feature to the score that the essay received, and then do the training. Then this trend model is used to find the score of the new essays. Then we can see in the textual similarity, it is also the method is used for automatic grading of the essay. In this case, students answer and the reference answer, they are compare. Similarity between them is find out. Okay, and for that we have to convert these students and reference answer into the word representation. And already we have seen the many techniques are there to find out the textual similarity. That is LD distance, cosine similarity, Euclidean distance. Many techniques are available for that purpose. Then neural network based approach. So here we can see that it is the one of the machine learning approach only, advanced machine learning approach. So neural network also we can have the artificial neural network, and we can have the deep neural network. So in the artificial neural network, here we have to provide the manual feature. So we require the feature engineering in artificial neural network. So and if you see the deep network, here we don't have to give the features as input. So this is the beauty of the deep neural network. It is doing automatic feature extraction. It finds unique and complex features. While the deep network is related to data transformation and extraction of feature, which attempt to establish relationship between essay and its assigned score without any feature engineering. If you see the example of the deep networks are the convolutional neural network, long short-term memory, recurrent neural network, multidimensional long short-term memory, etc. Many deep learning techniques are available. And now if you see the naive-Bayes classifier, so it is used to find the most likely hypothesis class. It is a probability of hypothesis based on prior probability. Here we can see the formula. It is find the probability of the hypothesis HI. And here we can see that H map is the maximum likelihood hypothesis, and D is the feature vector. Here we can see that D1, D2, Dn, these are the set of the attribute which describe the data. And here we can see that if we'll estimate this, if suppose we'll assume that these features are dependent, then large number of samples are required, and we have to calculate the joint probability for all possibility, which can be computationally costly. Hence Naive-Bayes classifier is used. So how the Naive-Bayes classifier is different? So here it assumes that all attributes in D are independent. That is why here we are calculating the probability of the individual attribute for that given hypothesis. We don't have to consider other attribute at that time. So here thus the joint probability is obtained as given below, because here what they are independent, they are not dependent. So it only estimates the probability distribution for each attribute, and it don't calculate it for all the terms in this way. It is just calculating for that individual attribute, means probability of D1 for the hypothesis HI. Then again for D2 for the HI in this way. And from that it is finding the most likely hypothesis. Now this is the comparative study by using the different approaches. So just for reference, I have taken this 6 references, 6 papers. The authors authors have done use this ML approach, DL approach, and similarity matrix. So here you can see that in the first one they have used the similarity matrix. So here we don't require the features. Only thing is what we have to convert this student's document and the reference document in the vector representation, and they have found the similarity by using the Dice coefficient, and this root mean square error is used for the model evaluation. Then in the second approach they have used this DL approach, and they have used the ML approach, and these techniques are used, and they have find the quadratic weighted kappa for all these techniques. And here we can see that this DL approach, it is giving the more similarity, more quadratic weighted kappa value. And then in the third one, here we can see that they use a DL approach. So no feature extraction is required, no feature engineering is required, automatic feature extraction will be done. And they have used found this F score as the evaluation metric. Then in the next technique, we'll see they have used this similarity matrix. Approach. Now, commonly used metrics to vary the performance of are some of the widely used methods for grading essay type answers. The commonly used metrics to vary the performance of the models built for automated grading of the essays are quadratic weighted kappa, recall, precision, and F1 score. Also, comparison of existing approaches based on this identified feature is presented. The presented work can be extended to build standard data set consisting of student responses to the essay question classified according to Bloom's taxonomy level, and then to develop a useful machine learning model for this purpose. So this will be future work. So these are the some of the references that I have used in my presentation. And thank you. Thank you.
Thank you. Is there any questions from audience? Thank you.
All right. I think there are no more questions, right?
Yeah.
Yeah. So I think this one is the last paper, right? In this session, now we are finish all papers in this session today. And now thank you very much for the participants who have presented their paper and who are attending online. And thank you very much for you guys, you are presenting here. So we will start our tomorrow morning session again, keynote session. And I'm going to upload the Zoom link for the tomorrow session at website, IHCI webpage as well. So bottom of the web page, you can access the Zoom link as well for tomorrow's session. And is there paper ID is 61? Somebody is asking. Paper ID 61. So do you want to present 61 paper ID right now?
Yes, you can.
Yeah, please go ahead. If you want to present, you can go ahead right now.
Yeah, okay.
Okay. So you can share your screen. Yes. All right. Thank you very much. Go ahead.
Can you see the presentation?
Yeah.
Yes, we can see. Perfect.
My name is Youngjin Kim, and the research title is Analysis of User Preference of AR Head-Up Display Using Attractive. It's outline. And for the first time, motivation. The head-up display necessary for military and civil aircraft is growing rapidly with the emergence of a variety of new markets such as automobile, sports, and infotainment. And the global automotive head-up display market is expected to grow from $3.71 billion in 2020 to an annual average growth rate of 28.54%, reaching $13.02 billion and 15.6 million units in 2025. So the purposes of this research is to define what elements should be strategically utilized for the future car AR head-up display development by using attractive in automotive head-up display design to analyze user feedback according to the graphic style of the head-up display. And to establish a guideline, what elements should be strategically utilized for the future car AR head-up display development as an early stage study. And the background information and related works. Recently, AR head-up display has been mainly developed in the head-up display industry. Volkswagen adapted AR head-up display developed by LG Electronics for 2009's new electric vehicle ID.3. And the AR-based head-up display mounted on the 7th generation S-Class that Mercedes-Benz will release guides the navigation route along the actual road, and it is capable of warning the user of dangerous situations on the road. And according to the Mercedes-Benz, the experience is like viewing a 77-inch monitor from 10 meters away. And research has been conducted on AR head-up display cognitive response and element design of displaying information, whether visual demand is reduced, and preference area of displaying information, and driver's viewpoint tracking technology, etc. So prior studies showed necessary to conduct the study from user experience perspective regarding the difference between the AR head-up display and the currently used 2.5D head-up display graphic style type. Therefore, in this study, in designing a car head-up display, the user's feedback according to the graphic style of the head-up display is analyzed using attractive to define what elements should be strategically utilized for the future car AR head-up display development. So to analyze user preferences of two types of car head-up display graphic style, as shown in table, 500 Koreans, 250 males and 250 females, and age group of 20s to 60s were surveyed. A survey was conducted to determine user preference regarding the two types of head-up display graphic styles. The left side picture is 2.5D head-up display, and right side picture is AR head-up display. The survey was conducted to measure user preference based on 28 factors in the following 4 categories: pragmatic quality and hedonic quality identity, and hedonic quality stimulation and attractiveness. So the result of the survey was analyzed using attractive's 7-point scales for 28 factors. The 7-point scales is from -3 point negative words to 3 point positive words. And the result, when comparing the 2.5D and AR head-up display types as shown above, the AR head-up display type had 0.2 points of hedonic quality identity and 0.4 points of hedonic quality stimulation and 0.1 points of attractiveness higher than the 2.5D head-up display type, and the pragmatic quality was 0.39 points lower. And as shown in this figure, when comparing the 2.5D and AR head-up display by using the attractive usability evaluation, the 2.5D head-up display type was more neutral area than AR head-up display type in its connection to pragmatic quality, hedonic quality. And AR head-up display type, on the other hand, belongs to the self-oriented area more than 2.5D head-up display type. And finally, as shown in this figure, the result of analyzing the details which indicated that 2.5D head-up display type was 0.39 points higher than the AR type in pragmatic quality showed that based on the 7 detailed evaluation criterion of pragmatic quality that contains technical, human, complicated, simple, impractical, practical, cumbersome, and straightforward, unpredictable, predictable, confusing, clearly structured, unruly, manageable. So 2.5D head-up display scored higher than AR head-up display type. So overall, the 2.5D head-up display type tends to be evaluated to be more practical than the AR head-up display type. And a result of analyzing the details which indicated that AR head-up display type was 1.39 points higher than the 2.5D head-up display in hedonic quality stimulation, showed that based on the 7 detailed evaluation criterion of hedonic quality stimulation that contains conventional, inventive, unimaginative, creative, cautious, bold, conservative, innovative, dull, captivating, undemanding, challenging, ordinary, novel. AR head-up display scored higher than 2.5D head-up display type. This is the biggest difference in the assessment among the 4 core characteristic elements: pragmatic quality, hedonic quality identity, hedonic quality stimulation, and attractiveness between AR head-up display and 2.5D head-up display. Overall, AR head-up display type has a special advantage over the 2.5D head-up display in terms of hedonic quality stimulation criteria. So the summary of research is guidelines are specified to what elements should be strategically utilized for the future car AR head-up display development as an early stage study. And AR navigation system shows its satisfaction with hedonic quality identity and hedonic quality stimulation attractiveness are higher than the 2.5D navigation system. So it is necessary to maintain the advantage of visually appealing, especially stylish, premium, bold, novel, attractive, etc. because it provides a new and innovative experience by displaying information display elements in a sophisticated graphic style according to the road situation. And third, the 2.5D head-up display type's satisfaction with pragmatic quality was higher than the AR type. It seems that this is so because of the AR head-up display type's unpredictable information display elements, which may prove to be difficult to discern, indicating that the graphics design should be supplemented in a direction to minimize the disadvantage attributed to AR head-up display, such as complicated, unruly, cumbersome. And future work. This study is not a prototype in which the technology is actually implemented in the case of AR head-up display, and there is a limitation in the part where the questionnaire was conducted only with the image of each head-up display graphic style type. So therefore, This study is meaningful as an early stage study in defining what elements should be strategically utilized for the future vehicle AR head-up display development. These are references, and thank you very much. Any questions?
Is there any question? Anybody, audience, want any question from the author? No more question? Professor Arvind, do you have any question?
No.
All right. So I think thank you very much. There are no questions from the audience as well. So thank you so much for your time and presentation. All right.
Yeah, thank you very much.
Yes, thank you so much. And for the tomorrow session, we have already texted in the link. You can see here from the Zoom text, we have already shared the tomorrow sessions link here. So you can copy it from here, as well as we are going to update at the website, IHCI webpage. We'll update tonight as well. So you can join again for tomorrow's morning session from the keynote. We have, I think, 5 keynote session for tomorrow. And then after it will be start again for the session 5, 6, 7, 8 will be the tomorrow session. So we will share the link, and like after the keynote session, we will share other links as well. And most of the sessions link we are going to update over the web page. And who has joined the chat box, we are going to also update there in the box. All right. So I think this is from us. That's finished for the today's sessions. So we are going to meet you all tomorrow again. So thank you very much for your time and participating in the sessions. So thank you very much.
Thank you very much.
Yeah.
Thank you.
Yes, Professor. Thank you.
강대희 교수님. 네. 오늘 주무시고 하십니까? 네. 그럼 같이 가시고 저녁도 같이 드시죠. 네.
So let's see another session going on or not?
하는데 요새 무슨 피곤하네. 그래서 문 닫히게 안 되니까 이게 편하지가 않아요. 그렇죠. 항상 일하는 집이 아니니까 좀 불편하죠. 놀러 다닐 때 좋은데 이게 놀러 다니면 일이라고 생각해서 그래요. 여기는 이건 누구 건지 모르겠네요. 이거 충전기를 놔두고. 네, 뭐 놔두고. 놔두고 아니면 내일. 맞아요. 그대로 쓰면 돼요.
All right then.